So today we are going to start a new topic called linked list data structure. So a bit important and useful topic. See, first of all, in general, especially with respect to the Java, what is variable? Variable means what? It is used to hold some data. Sir, how many values it can able to hold? Sir, it can hold only one value at a time. How many values it is going to store at a time? Only one value. Sir, these problems are there with a variable. Sir, I have some 5 to 6 values are there. How I can able to store? For that you need to go for which concept? Arrays concept. Sir, what is mean by array? So array is nothing but it is also a variable. So it can hold any number of values. Okay, by using sir some index, by using single name and index concept. But still there are some disadvantages with arrays. What is the disadvantage? Sir, whenever you are creating an array like integer a is equal to new integer of 5. Now this array a can store how many values? Only 5 values. Sir, when the program is executing, can I give one more value like sixth value? No. Can I delete one value? No. So during runtime, is it possible to add any content? No. Is it possible to remove any content? No. That's why, so to overcome this problem, we are going for collections. What is mean by collections? Sir, it is used to hold the values, but it is growable. It is growable. Growable means what? When program is executing, if you want, you can add the objects. If you want, you can remove the objects. If you want, you can update the objects. Like all these operations, happily we can do. So this is called as collection. I hope the terminology related to the variable, array and collection, it is very clear for you. I think so. Any questions?
No, sir.
Sir,
Right.
No, sir.
sir, one more point regarding the arrays. The array can hold only homogeneous type of elements, right?
Yeah, yeah. It is also a point, but actually our main intention is what? Size, based on the time talking. Okay.
Okay.
Yeah. So, but in collection, there is one special class is there. Do you remembered or not? In util package, they have defined one class with name linked list. Sir, internally, it uses a double linked list. Okay. So, but there is one predefined linked list class is there. Sir, what information is there in this linked list class? So already they have implemented one data structure called a double linked list. So what are the common operations that we can able to perform? They implemented and they provided as a ready-made method support for us. Just what is your requirement? Just you need to take, you need to create object and just invoke that method. That's all. But what about our class? It is not to implement, sorry, it is not to use those methods. We are going to create a linked list kind of a structure by using some Java program. So if you understand this linked list, maybe today, tomorrow, this entire week, so you will get a clarity like internally. So we are using so many ready-made methods directly, but how much story is there beyond that? You people are going to get a clarity. Okay. So this is nothing but just at very top level. Do you have any queries up to this?
No, sir.
Right. But anyway, in Java, in a predefined implementation, they are using double linked list. But when it comes to the theory, there are four types of linked lists are there, sir. One is single linked list, in short form SLL. So next one is double linked list, DLL. Circular single linked list, CSLL. Circular double linked list, CDLL. Like that we have, friends. But don't worry, all these things we are going to store. I mean, all these things we are going to see. Sir, but how you are going to represent the data? How you are going to represent the data? In linked list, the data is represented in the form of a node. In the form of a node. Sir, node means what? It is used to. It is used to hold the data, and it contains two parts. Two parts. In this, there are two types of nodes are there, sir. One is single node, where you can store data and pointer to the next node. And when you have double node is there, you will store data, next pointer, and also previous pointer. Sir, I will show you just a diagrammatic representation of these nodes so that you will get clarity. Sir, do you know this is called as single node? This is called as a single node. It will be having only two fields. What is this field? To contain data. What is this field? It is a pointer which is pointing to some other node. Sir, what is that node? It should be also same node type only, like that. Sir, when you are talking about a double node, what will happen? Sir, 3 fields will be there. One is to store the data, another one is to point to the next node. So one more pointer will be there pointing to the previous node. Friends, clear up to this, the terminology?
Yes, sir.
Yes, sir.
Right. Now, just for your reference purpose, I'm going to write some linked list like this. Just I'm going to write a linked list format like this. So what is the first node? Next field is this one. Second node next field is this one. Third node next field is this one. Sir, fourth node next field is null. Null means there is no other next node. Sir, something like 10. So 11, 12, 13, like that. Sir, is it a linked list or not? Just visualization. Is it a linked list or not? Please tell me. Come on,
Yes.
speak.
Yes, sir.
So there are some terms which I am going to use every time. The common terms in linked list. Sir, what are the common terminology that we are going to use in the linked list? Sir, the first terminology, head. What is mean by head? It represents the first node in linked list. Sir, head represents what? First node in the linked list. There will be another pointer with name tail. Tail means what? It represents last node in linked list. It represents last node in the linked list. And already we covered about data. Data means what? Sir, which contains actual content. Which contains actual content. What about next pointer? Sir, it is a pointer. It is a pointer pointing to the next node. It is a pointer pointing to the next node. Sir, what is mean by previous? It is also a pointer pointing to the previous node, like that we have. Sir, in addition to that, while doing the program, there may be a chance of storing some data. For that, we are going to use some nodes like a temp. Temp is nothing but what? It is a pointer pointing to some temporary node. Sir, when you have more than one temporary, temp 1, temp 2, like that we will use. Because while explaining the program, I am trying to use these terms. So at the time, you should not get any doubt. That is the reason why I covered now itself. Do you have any queries up to this?
So this node means it is like two variables or how it is, sir? The node means
I already told, right? You can see this is the node. How we are representing that I will show you in the program.
exam. Okay, sir.
Friends, clear?
Yes, sir.
Yes, sir.
Right. Sir, please be active. So now, what are the common operations? What are the common operations that can be performed on linked list? Sir, whatever operations I am telling applicable for all the linked list, but I will explain only for single linked list. Double linked list, circular linked list, those things you have to implement. Majority of the operations I am going to cover on single linked list. Remaining things you have to do. Very top level operations only I will explain in the remaining cases. Sir, we have around some 30 operations are there, friends. What is the first operation is defining node class. Sir, I want to represent a data, sir. First of all, you need to take a node, right? Without taking a node, how you are going to take? That's why, so directly I'm going for the program. So to explain this, I'm going to use one IDE, which is nothing but Eclipse IDE. But before that, let me add some two more operations. What is the second operation that I'm going to do here is, so the second operation is defining single linked list class. Third one, sir, size of the linked list. Then fourth operation, whether linked list is empty or not. Okay, whether linked list is empty or not. So without giving any delay, I am trying to explain these four operations as of now. Please listen carefully. Sir, here I am going to take a new project for doing this operation. Let us create a new Java project. So name it as triple W. So now here I'm going to take a new Java class. The name of the class I'm taking SLL. Sir, I got SLL class. Now to run the program, you need to create one test class, right? So I'm defining test class with main method. I'm defining a test class with main method. So now our main program we are going to run from here, but remaining definitions and all we are going to implement in that SLL class. Sir, if you take SLL class, what is the first thing that we need to do? Sir, we need to define a node, right? So inside this, I am taking class node, but I want to access this node everywhere, right? Better to take it as a static. You know the concept, this one very well. Next, every node contains how many fields? Since I am talking about a single linked list, there must be two fields. What is the first field? Integer data. What is the second field? Node next, pointing to the next node. And I am taking one constructor here while creating the node object. So I will pass data and the next pointer. Whatever data you assign, that I am going to give to the current node. and whatever pointer you are giving, that I am giving here. This is nothing but node class. Similarly, integer size of the single linked list, and node, there are two main pointers I am taking. One is a head, another one is a tail. Then single linked list constructor I am taking. In the constructor, what is the initial size of the linked list? 0. What about head element? Initially it is null. So what about the tail element? It is also initially null. Just I created one class for node which contains how many fields? Two fields. One is to hold data, another one is to point to the next node. Do you have any queries up to this?
Sir, why you are taking inner static class here, sir?
Because in single linked list, whatever operations that I will perform, in that class only those methods will be there, right?
Yes, sir.
So suppose if I want to insert any new node, then where we need to define that method? Inside SLL only, correct?
Yes, sir.
So that's why. Because if I define that node outside, what will happen? Security issues will come, right?
Yes, sir.
Sir, clear everyone?
Yes, sir.
Sir, why did we take node as static class? I did not get actually that one.
Sir, actually, that's why Java concepts you should aware very clearly. Whenever you have a class like SLL, if you are not declaring this class as a static, what will happen? So you need to create SLL class object. By using that object only, you have to create node class objects. If static is not there, if static is there, what will happen? Directly you have an access to create node class object. Something like regular inner classes, okay, static nested classes, that concept. Got it?
Okay.
Yeah. So anyway, that video is there in our YouTube channel. I will share that in the group today. Just refer it once, you will get clarity. As
Okay.
of now, it is not required.
Sure.
And here the fifth line, we can take string also, right, sir? Why it is again node? Reference we can store in the
Sir, actually
string
node
also.
means this is right.
Correct,
Diagram wise, here the content is there.
correct.
It is a pointer which should be pointing to a person. No, right?
Next node. Oh,
It should be again a node, correct?
oh, okay.
That's why the same type I'm going to take.
Oh, okay, sir.
Yeah. Can I define the methods one by one? So what is the first method?
Okay.
I want to find size. I want to find size of the linked list. Can I take integer get size as the
Sir, I
method?
have one more question, sir. Sorry,
Yes.
sir. Sir, actually, no, line number 5, the node is so next. We can also take int node instead of node. So it will be also a container, no, sir?
Sir, that's what I explained, sir. See, when you are taking any node here, 10 is the data field. Next one is a pointer. Sir, where it should point? Is it going to point to any person? No,
Okay,
right?
okay.
It
Yeah, yeah.
should point to the node only. This is
Yes, sir.
called a node. This is called a node template class. Got it?
Yes, sir.
Yeah. So integer get size. So return this dot size I am taking, because anyway size variable is there. Simply you can ask, sir, what is the time complexity of this method? Big O of 1, because you need time. Now I want to check whether the linked list, is empty or not. How to check? Return type is boolean, is empty is the method name. Sir, how you can say whether the linked list is empty or not? If the size of the linked list is 0, return true, otherwise return false. What is the time complexity for this? Big O of 1 only. Got it, friends?
Sir, I have one query here. So you have defined SSL node Noah constructor.
Hmm.
Size should be incremented, right? Every time we are
Sir, constructor purpose is what?
create a new object.
Sir, who told, sir? Constructor purpose is not to create objects, sir. You people are lagging in OOPS concepts. Please study well. Constructor purpose is only to perform initialization.
Okay.
Initialization means what? At very beginning values. Tell me what is the size of the linked list at very beginning? 0 only, right?
Yes.
That's why.
Okay.
When it will be incremented? When a new node is inserted. That means in the
Okay.
insert function, we will write that code.
Okay.
Sir, everyone clear with these two methods?
Yes.
Right. But don't worry. I want to check whether these functions are working or not. To which class you need to create object? Single linked list. List is equal to new single linked list. Sir, can I take system.out.println list dot get size, which is going to return size of the linked list. System.out.println list dot is empty. What is output? My list is empty. True. What is the size? 0. Let me check. Sir, 0 and true. Everyone clear?
Oh, yes, sir.
Yeah.
Sir,
Can I go for next methods if you are clear up to this?
Yes.
Right. So what is the next operation is very, very important. Insert. Insert operation. But for insert, multiple ways are there, sir. One is, sir, I can insert at first. I can insert at last. Sir, I can insert at a specified location. Your choice. But as of now, let me talk about insert at first. I want to implement that. Sir, what is the method name I will take? Void insert at first. What is the argument you will give? The data. What is your task? You have to insert at the data. So inserting a node at the first location. Now, sir, at the very beginning, tell me, do you have any nodes? No, right? At the very beginning, do you have any nodes? No, right?
no, sir.
So what is the first step that you need to do? You need to create a new node, correct?
Yes.
Yes, yes.
And you need to give some name for that. Let us consider the name is nothing but new node. So what is your first job? You need to create object for node. New node is equal to new node. What is the data, sir? Already they have given. What is the next field, sir? Null. That means in the diagram, the data field is a 10. Next field is null. Sir, is the first line. Is it clear?
Yes.
Yes.
What is the
Yes.
initial value of size? 0, right?
0.
Now this node got created, right? We have to increment by 1 unit. So size plus plus I am taking. Sir, any
Sir,
doubt in these two lines?
yeah, sir, null is a reference, right?
Sir, null means what? When there is no object, we
Yeah,
will
yeah.
make it as null. It is
Okay,
not
but in
reference.
this diagram, 10,
Hmm.
10 is the data and the second point is the reference to the next node, right?
Because there is no next node, that reference is
Okay.
pointing to null.
Okay, yeah, thanks.
Yeah. Hmm. Sir, clear up to this?
Sir, I
Yes,
have
yes.
one query here.
Hmm.
So basically, the method is insert at first.
Hmm.
Okay.
Hmm.
Now, suppose there are already 4 nodes are there in my linked list.
1 second, sir. We are on the top of well, sir. Just we didn't jump into that. Just we are at very top. We are
Yeah,
seeing what is happening. Wait,
yeah,
wait. First, let me create a node.
okay,
After creating one node, if we are trying to create a second node, what will happen? Then I will explain. Okay.
okay.
Any questions on these two lines?
No.
No,
Right.
sir.
Now I have one question. Sir, before creating this node, tell me how many nodes are there in the linked list? 0, right?
Yes, sir.
Yes, sir.
Yes,
So if head is equal to null, what is mean by head? Very first node in the linked list, correct?
yes,
Yes, sir.
What is the head value initially? Null, right?
valid. Yeah,
Now whatever node you created, this node will become head node. Am I right?
Yes, sir.
And this is the last node, right? Can I say this will become tail node?
Yes, sir.
So because
Yes.
we don't have any other nodes, we
yes,
created only one node. That one node will become both head and tail. Am I right?
yes,
When
Correct,
this
sir.
will happen, if a head is equal to null, then head is equal to tail is equal to the newly created node and terminate the program. Can you please confirm once if you come out from this method, where new node name we declared in this particular method? Sir, once if that method execution completed, this reference will be by default gone. Now the name of the node is nothing but what? We don't know. What is the first node? 10. What is the last node? 10. How many nodes are there? Only one node. Got it, friends?
Yes, sir.
yes, sir.
Now, sir,
Sir,
second time I'm trying to create a node, sir. Second time I'm trying to call this function. Now again this line will execute. Now what will happen? One more node it is going to be created. Can you please confirm where this node has to come? At the beginning of 10 or ending of the 10? I mean before 10 or after 10?
After 10.
Before 10. Sir, why? What is the method that we are implementing? Can you please cross check?
Insert it
Inserted
first.
first.
Yes, sir.
Now, whenever this node got created, let us take 5 is the data. Next field is null. What is the name of this node? New node. This line, okay. Then size plus size will become 2. Any queries up to this?
yes, sir. Sir, in first node,
Hmm.
so just like it will refer, just like in the first node here, 5 value is null. So
No, no,
how
no.
it
1 second. In your point of view, which is the first node? 10 or 5?
now it's 5, sir.
Not, I didn't explain that part. So your doubt is, do you have any doubt in these two lines for the second node, which I created?
No, sir.
Then leave it. You will get clarity now. Okay.
Yes,
Yeah.
sir.
Sir, now tell me the next line is head is equal to null?
Yes, sir.
No, sir.
No, because
No.
are you seeing head is pointing to some node, right?
Yes,
Is it
Yes,
null?
sir.
No.
no,
No.
it is not
That
null.
means this condition is never satisfied. Correct?
Yes,
Now
Yeah.
tell me what will happen. New node dot next is equal to, can I take it as head? That means what? This is the new node dot next, right? I am making this next node is nothing but which one? Head node. Got it,
yes,
friend?
right.
But which is the first node? 5, right? We need to change that one also. How to change? Can I take head is equal to what? New node. That means head is nothing but which one? 5 from now onwards. So these references will be gone. Clear, friends?
Yes.
Yes, sir.
Now let me add a comment and I will give one more example. When this will execute, if list is empty, that means what? At very first time.
Yes,
Sir,
sir.
what about this one? If list contains some nodes. Clear?
Yes, sir.
Yes.
Now, sir,
So
one
head
more
is used
example.
for the first node like that, right, sir?
Mhm.
The head node always be points to the first node only. Tail nodes is always points to the last node only, like
In
that.
this case, because see,
Oh,
we have a chain, sir. This is the starting point of the chain, and this is the ending point of the chain. So I am adding these links to the beginning, not to the ending. When you are adding like this, tell me which is the beginning? This one only, right?
yeah, yes, sir.
Which is the ending? This one, right? Is it going to
Oh,
change? No, because what type of operation you are doing? You are adding always at the beginning. So you didn't
yes,
add
sir.
it at ending, right? If you add at the
Oh,
ending, then it may change.
okay.
Understood, sir?
Yes, sir.
Right.
Sir, one query here.
Hmm.
So, should we also, while we are defining insert at first,
Hmm.
should we also now declare tell also? I mean, define tell also. We need to point tell also, right? Of the new node,
So I'm
sorry,
not
of the
getting. Can
linked
you
list.
please repeat?
So basically, in linked list we have head and tail, right? I mean,
Hmm.
both pointers we
Hmm.
have.
Hmm.
We have defined head here.
Hmm.
Okay, so tell. Okay, so tell no. Okay, so we don't need to assign tell in this method. Insert at first, right?
No, that's what I told, sir. Same doubt only again you are asking. Tail
Yeah,
is always fixed, right?
yeah.
Are you adding at the ending? No. If you
No,
add at
no.
the ending, tail may change.
Correct. Yes.
Yeah. Now let me take one more example. Sir, I am adding one more node. So let us consider the content is nothing but a 2. So next field is nothing but a null. The name of this node is nothing but what? New node. Tell me where this node should come. Sir, this node should come to the beginning. Sir, is the list is empty? No. Then what will happen? Sir, new node dot next will become what? Head. So new node dot next field will become what? Head. So after that, your head will become what? New node. Like that, I am changing. So after that, this one will be gone, this one will be gone. Are you clear?
Size also should increase, right, sir?
Size already I updated, you can check. Clear?
Yes, sir.
Yes, sir.
Right. One second. Sir, no doubts, right, up to this?
Sir, Node have two part. One is a container, and second is a next. Sir,
Hmm.
next is taking the address of the node.
Yes.
So, sir, just like address is a hexadecimal number.
Sir, in C language, you can print and you can see what is happening. But here, just like assume it is a pointer pointing to the next one, definitely it holds the address only in hexadecimal form only. But we are not required to deal with that, right?
Uh, so,
Correct.
yes, sir. So, oh, sir,
So
sir,
that address only you can point by using next pointer.
Okay. So instead of node, we can also store the address.
Sir,
Instead of node reference, we can also directly can store the address.
sir, your question is something like different, sir. Here node is there, data is there, next field is there. You are talking about which one?
Yeah, just like sir, second node in middle node 5.
No,
He's
no, I am talking. Tell me the term among these three. Which term you are talking?
I am talking about the next.
Next means what? It is a pointer. See, there is a structure we defined, like a
Yes.
class node. Inside this, how many fields are there?
2.
Two fields. One is nothing but holding the actual content. Second one is nothing but a pointer.
Yes, sir.
What is this pointer?
Node.
It is pointing to the another node, right?
Yes, sir.
So that means this node only, right? That class reference only I am taking here. This always represent address of the next node.
Yes, sir.
Got it?
Yeah. Yes.
Right. Sir, let me check up to this. Let me check up to this. Now listen, I am trying to take list dot insert at first. First we added 10. So then we added 5. Then we added 2. Now what is the size? 3. Is the list is empty? No. You need to get false. Let me check. Friends, is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Is it working or not?
Yes, sir. Working.
Yes, sir.
Right. Now my question, what about the content? We will see later. Can you please tell me, for inserting the element at specific position, what is the time complexity of this algorithm?
Big O of n.
Very good. Big O of
N.
1.
1.
Not n. See, if you want to add any element, where you need to add now? Before 2, correct?
Yes, sir. Yes.
Are you going to disturb the links between
Right.
2 and 5 and 5 and 10? No, right?
Right.
So what is the indirect mechanism I told? Is there any loop in the code?
Oh, sir.
No. If there is no loop, then it is not big O of n. Correct?
That's
Right, sir.
Clear? If you are clear, then I will go for the next two methods. Clear?
Yes, sir.
Sir, visually it is okay, but can I see that list in the output? Yes. So printing the list, I am going to display now. So void, I will take print list. Is it going to take any arguments? No. Sir, tell me, there are two cases. What is the first case? If the list is empty, what you will do? So if the list is not empty, what you will do? If the list is empty, what you are going to do? Simply you will print a message. What is that message? If some condition is satisfied, I am printing a message saying system.out.println. So list is empty. Gaurav, please be on mute. List is empty. Like that we are printing and coming out from the method. But sir, tell me when we can say list is empty, head is equal to null, correct?
Yes.
Yes, sir.
If head pointer is pointing to null because initialization, then list is empty.
Or size is
Otherwise,
0,
yes.
right?
But don't take size every time because we have a pointers, right? Better to deal with
Okay.
that.
Okay.
In the circular case, we can take, but here not required. Otherwise, how many elements are there?
Now 3.
3. How you can represent all these? Not possible, right? That's why what I am going to do is I am taking one special pointer called a temp. Special pointer called a temp. Sir, initially this special pointer is pointing to the node 2. Tell me what is the code for that? Anyone?
First, we have to create a node. Name is
Can I
temp.
say temp is equal to head? Correct?
Yes,
But
sir.
temp is what type?
Node.
Node
Node
type.
type. Are you clear this line?
Yes.
Yes.
Now you need to print, but we don't know how many objects are there. Correct?
Yes.
If you don't know how many objects are there, which loop you need to take?
While.
Fine.
While. So I am printing system.out.println of temp.data. Temp.next means next pointer. Temp.data means this pointer. Don't use head. If you use head, what will happen? Only first node data you will get. Up to this clear? In the output, what will happen?
Yes.
What is the temp data? 2. Now I want to break this link. Now onwards, my temp should point to this node. How you can give that?
Temp is
Temp is equal to temp.next. Correct?
Yes.
Can I
Sir.
print that data now? 5. Now again what will happen? Temp is equal to temp.next. It will print 10. Now this will break. Now tell me what is a temp node? Null, right?
Also.
Now what is the condition? While condition. Until the value of temp is not
Temp
equal
dot-
to null, we are printing. Correct?
Yes.
Clear, friends?
Yes.
Sir,
Let me check.
line number 58. Temp is equal to head dot next. We can also write.
Sir, actually we should not disturb head, sir, because head and tail are fixed. Why we are using temporary? There may be thousands of nodes will be there. One by one node we have to visit. If you take head dot next, it is okay. But again, it has to work, right? If you take again head dot next, what will happen? Where head is pointing to only, right? Every time head dot next is 5 only. Correct?
Yes, sir. Yes, sir. And,
Got it?
yes, sir. And one more question is that, sir, you are taking a temp. Temp is a node, and it has two part. One is a container, and second is a address. So first part is empty always for
No,
temp.
sir. Sir, here it is printing the data, right?
Okay. Yeah. Yes.
Got it?
Yeah.
See, head part is nothing but a head node. I am talking head means this entire node. Temp means this entire node. Got it?
Yes, sir.
Now see. So let me execute this.
Sir, this time complexity will be 0
I
of
will explain, sir.
big
I will
of
explain.
n, right?
I will explain.
Of
I will
n.
explain. I will explain, sir. Please wait. Now I am removing this size and is empty. So list dot I am taking print list. Let me execute. Sir, are you getting 2, 5, 10?
Yes.
But now I want to print in the normal style in how linked list is appeared, not line by line. So how you can do? Can I remove this print ln? And after completion of this while loop, I will give this print ln. Now observe. Sir, here also let us give some space. Now see. Is it clear?
Yes, sir.
Yes.
Now list dot insert at first of 999, then list dot term. So insert first of 888. Now tell me what is output?
8899
888 999 2510. Correct? Clear, friends?
Yes, sir.
Yes, sir.
Yes.
So now what is the time complexity for this? Big O of
Of n.
n.
Yes.
Why? Because we have a loop Suppose if the list contains some 100 elements, we have to visit all the 100 elements. That is the reason. Clear?
Yes.
Yes.
Understood, guys?
Yes,
Yes,
sir.
Yes, sir.
yes.
Now, sir, I am doing some small modification here. Observe. Linked list L is equal to new linked list. So L dot add first. L dot add first of, I am taking 111. L dot, so add first of 222. L dot add first of, so 333. After that, system dot out dot print ln of L. Now observe, I am running this code.
Sir, line number 15.
Yes.
Linked list E.
Enumerator.
Okay, okay. It is expecting the type. Okay, no need. Now see. Sir, what is the print difference between our linked list class and predefined linked list class? Are you seeing the predefined linked list objects are displayed in a stylish form within square brackets? All the objects are there separated by commas. But our print method is not like that. That is a one difference. Second difference, they are calling directly, they are printing the object. But here we are not printing the object. We are printing a separate method. Sir, if I print direct objects, what will happen? Sir, it is going to print the address of that particular class. Are you seeing single linked list class at the rate so and so memory location? Sir, I don't want this. If you don't want this, we have one weapon, right? We have to override which method? ToString method. That is our concept now. Clear?
Yes, sir.
So I will implement ToString method in such a way that it should print in this style. Can I go for that? Please confirm.
Yes, sir.
Yes.
Yes, sir.
Right. So which method we have to override now? Overriding ToString method. Sir, can I say time complexity is big of n? Because compulsory we have to print all the objects, right? That's why. Now, observe carefully. This method should be public string. Method name is nothing but what? ToString. Now, sir, how to print? It is a typical thing, sir. I am going to declare one string buffer. String buffer SB is equal to, so new string buffer I am taking. Sir, after this, SB dot append of open parenthesis. Observe friends, I am appending open parenthesis. Okay, one open parenthesis came. Now, so what you need to do? Sir, node temp is equal to head until temp is not equal to null. Until temp is not equal to null, what I am doing? SB dot append of temp dot data I am appending. Sir, can I say 2 will come here, right? Yes. But after that I need comma. How to add comma? Plus comma. Now temp is equal to what? Temp dot next. This process will repeat. So first it will add 2, it will add 5, comma, it will add 10. Again comma will come. At last we need to close. How to close? SB dot, again append of. Now try to take the closed parenthesis. And at last you should not return SB because SB is the string buffer. You need to convert it into string. Sir, is very sample code. Clear?
Yes,
Yes,
sir.
sir.
Now let me execute. There is some small problem is there. I will show you how.
Sir, why we are returning last line in ToString, SB dot ToString?
Because ToString method always expects the return type as a string. But we did operations on string buffer, right?
Yeah, so directly we can return SB, no, sir?
Sir, you are not getting the point. The return type for toString method is always a string. If you take return SB, SB is what type?
String buffer. Okay.
Got it?
Yes, sir.
Yeah. Now see, everything is okay. But 10 is the last element, right? For that also, why you need to add comma? You should not write. So that part I am going to write now. Up to this clear?
It's also
Yes, sir.
extra space
Yes,
is
sir.
also there, sir.
Space is okay.
After,
Problem.
oh no.
Now see what I am doing. Sir, 5 okay, 2 okay, 5 okay, but 10. How you can recognize 10? Because it is a last element. How to recognize last element? Sir, if temp dot next is equal to null, that means we came to the last before. Last before node, don't add comma, only you have to add data. Sir, if it is last before node, no means, that means if it is not last before node, then comma must be required. That means what? First open bracket, this is a temp. Is it equal to null? Next node is equal to null? No. Then add the data, put comma. Sir, next time temp is this one. Is next field is null? No. That means 5 comma. So next temp is 10. Is next node is null? Yes. That means comma is not required. Gaurav, please be on mute. So it will
Got it.
print a 10. So after printing 10, what will happen? Immediately close the parenthesis and it will terminate. Like this is the beautiful code what we have. Now let me check. Sir, is the problem solved? Please confirm everyone.
Yes, sir.
Yes, sir.
Any questions?
Sir, the method that you just toString method that you just defined. Instead of temp.next is equal to null, we can also check if temp.next is okay. Okay, fine. Or if temp is equal to if temp is equal to tell, we can also check like that, right?
No, sir. We have to always think about next node, right? Not the current node. Think a bit logically, sir. Sir, after 2, whether we need to take comma or not, how you can decide? After 2, is there any node or not? We need to check. That means next compulsory you have to use.
Okay. Okay.
Yeah. Sir, if everyone clear, then one more operation is there. I will explain. Clear up to this?
Yes, sir.
Right. So what is that operation is? Sir, can you please add at the ending? This is my requirement. Insert. So insert at last. Insert at last. Void insert at last I am taking. Like integer data field. Integer data field. Sir, how you can add at the last? First, we need to create a new node with some data, and next field is nothing but what? Null. After creating the node, what is the next immediate step? Size plus plus. And if head is equal to null, whether you are adding at the beginning or ending, if head is equal to null, what is the meaning? The node which you are creating is the only one node. These instructions are very common. Now let me take one example. Sir, first time I am creating a node. Is there any node? No. Then the node which you are creating, this is nothing but what? New node, sir. This new node will become head and this new node will become tail. Correct, sir?
Yes, sir.
Now I want to create one more node like this. Let it be 15 is the data. Next field is null. This field name is new node. Now tell me where you need to add this 15, before 10 or after 10?
After 10.
After
10.
After 10. After 10. Now we have to link these two. Guess How we can link these two?
Move the tail to the second node.
Yes, very good. Tail dot next is equal to which one?
New
New
node.
node. New node. Then tail will become what? New node. Correct? So tail dot next field will become what? New node. Then tail will become what? New node. Clear, friends?
Yes, sir.
Yes, sir.
Any queries?
No, sir.
Now let me check. Already we have some content. So after this, I'm going to take list dot insert at last of. So 111 list dot insert at last of. So 222 and 333. Let me take system dot out dot println of. I am taking list. Tell me, is the objects got added at the ending or not?
Yes.
Yes, sir.
Clear?
Yes, sir.
Any
Yes, sir.
doubt up to this? So which operations we are pending? Insert at specified location. Correct?
Yes, sir.
Then
Yes, sir.
even we have seen how to printing a list. So then overriding toString method also I covered. Am I right?
Yes, sir.
Now, sir, tomorrow I'm going to explain the remaining methods. So in the remaining methods, insert at a specified location. It is a lengthy process. Then while displaying also, we have several versions are there and how to perform search operation and some special methods I will explain. After that, we will go for deletion. Sir, feeling comfortable up to this?
Yes, sir.
But the only thing what you need to do is tell me
Yes.
what you need to do.
We have to practice.
Yes, if you practice while coming to the tomorrow's class, you can get the flow, because how much time I have taken today, like that I won't take in the next classes. It will keep on moving. You need to understand what is next, what is previous, when you will go for creating a node, how the flow is happening, like that. Okay.
Yes, sir.
Yes, sir.
So you need to travel with me means you have to watch this video one more time and practice by taking paper and pen. Okay.
Yes, sir.
Okay.
Sir, in the last session, we started linked list concept. As a part of this linked list, we have seen very clearly like what is mean by linked list, how we can represent the linked list, what are all the common terminologies are there in the linked list. So next and after that, what common operations that we can able to perform on linked list also I explained very clearly. Okay, like what are the common operations that we performed? If you see our previous example, how to define a node class and how to define single linked list class and how to find size of the linked list. Next and after that, whether the list is empty or not. So insert at a first operation, insert at a last operation, and how to print the objects, overriding version of toString method I explained very clearly in our previous classes. Sir, up to this whatever I covered, Do you have any queries? Please confirm.
Think my side, sir.
Right. Can I go for continuation of this?
Yes, sir.
Right. Now, sir, actually because of time limit, I didn't discuss about how to insert an element at a specified location. Let me talk about one function. So how to insert at specified location. So here, what is the time complexity for insert at last? It is also big O of 1. Now, sir, I want to insert at a specified location. That means I will give some index. So into that index, I have to add the object. That is nothing but my requirement. But sir, how you can able to implement this particular program? For this n number of things we need to focus. Listen carefully. Sir, I am going to take a function, a method like insert atom location. Sir, first I will give index and I am giving data. What is my task? We have to insert the given data into the particular location. But to understand this, okay, let us consider a normal program only. See, we are going to give index value. If the value of index whatever you have given is less than 0, or the index value whatever you have given is greater than size minus. Sir, if it is the case, then what is the meaning? So if you are trying to insert in these locations, we can't insert. In Java, there is a term for this, out of range or out of bound, something like that. Then return the control. Sir, this is nothing but case 1. Sir, what is this case 1? If index is out of bound, then this is the operation what we will do. Are you clear with the case 1?
Yes, sir.
Yes,
Now,
sir.
second case. But before moving to the second case, assume that by default, what is the value of head? What is the value of head initially? Null, right?
Null.
What is the value of tail initially?
Null.
Null. Both are initially pointing to null. Am I right, friends?
Sir.
Initially, head and tail pointers are always pointing to where? Null objects. Okay. Sir, now the value of index, so which I am going to give here is nothing but 0, sir. And assume I am going to change the data. So first it is going to create one linked list. So what is the content? Assume that the content is nothing but 10, sir. The content is nothing but 10. So anyway, we know the next field is always what? Null. Now, since index is equal to 0, the node which I inserted will become head node. Am I right? Am I
Yes, sir.
right?
Yes,
Correct.
sir. Yes,
Now,
sir.
so in such a case, what I am going to do, sir, first we have to create node, new node is equal to, so new node of with the given data, next field is null, size plus plus, if index is equal to 0. This is one case. Sir, what is this case? This case is nothing but if index is 0, it is something like insert at first. Sir, when we are doing insert at first, what are the common operations that we will do? Sir, very simple. First we have to check. Okay. So new node dot next field will become what? Head. And head is equal to what? New node. And return the control. I am not talking anything about the tail because the list is already there. So if the list is already there, then only insert at location possible. Am I right, friends?
Yes, sir.
Now observe. Sir, what is
Sir,
happening?
why is the new
Hmm.
node dot next equal to head, sir?
Wait, I will explain, sir. Sir, please wait. Just follow my words. That's all. Coding part I will explain because minimum 2 notes I need to take to understand this. That's why. Now observe. Is index is equal to 0? Yes. What is the new node? This is the new node. Sir, new node dot next is equal to which field? Head. What is the head value? Null. Sir, that is null only already, right? Correct, friends?
Yes, sir.
New node next field is null, right? What is the head value? Head value is null only. Am I right, friends? Correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
Can I say this one I am going to assign in the next line as a head? Correct? Please confirm. Clear?
Yes, sir.
But sir, can I write any code here related to tail? Please understand at top level. We can't. Why? Because see, if the node is already there, if the list is already there, that means if the linked list is already there, whenever index is equal to 0, if you are trying to make it as a tail, what will happen? Already some nodes are there. You are trying to insert at which location? 0th location. If you change tail, what will happen? There is no meaning for the rest of the list. Sir, you got the point?
Yes.
Can you repeat, sir?
Sir, if the list is already there with some 100 elements, when you are trying to insert at 0th location, what is the meaning? So already 100 elements are there. So here in front of that, you are trying to add a new object, correct?
Yes, sir.
So this will become head definitely because this is the first node. Can I take it as a tail? No, because tail is already there. That's why I am not going to update any tail pointer here. Clear, guys?
Yes, sir.
Sir, I have one query here.
Hmm.
Sir,
Yeah, tell me, sir. Tell me.
yeah, actually, linked list is not linked list is not index based, right? It is not index based, right? Linked list.
Hmm.
So how why are we having some operation like inserting at index for linked list?
No, sir. Why? See, indexing is internally not supported like array. But you can ask, right? What is the fifth node in the linked list? Correct?
Yeah,
Then how you are going to return what is the fifth node? By counting.
correct. Yes,
Can I say it is something like index? In my point of view,
right.
because internally index concept is not there. Language
Yeah,
level they are not providing. But
correct.
because we are implementing, we can feel right.
Okay.
See, it is not like this. See, that's why I told, sir, majority of students, you people are having lack of Java knowledge. So please make sure you need to revise your Java concepts. Okay. Because if you see linked list class, in that linked list class, we have add first is there, add last is there. So we have special method like insert, which will insert at specific location. That means what? I want to add this object at this specific location. Yes, we can add. There is no problem. Got it?
Okay, sir.
We can add, sir. There is no issue at all. Okay.
Okay, okay.
Happily we can add. Sir, clear everyone?
Yes.
Any queries up to this?
Sir, the data node and the next node can be interchanged, sir. In the beginning itself, it is the same.
Sir?
In the node, we are taking the data and next, right? So we can interchange also then it is
I mean,
also a linked list. Yeah,
here you are adding,
correct,
you are
sir.
asking.
Correct, sir. Yes,
Sir,
sir.
it is a constructor, right? In
Yes, sir.
constructor, in which order you passed the parameters, in the same order only you take. In the constructor, what I did, first data field, then next field. That's why I am passing like this. If you want first next pointer and then data field also, okay. But there you need to change. But this is the common strategy generally programmers will follow.
Yes, sir.
Sir, why the value is null here, second argument?
Whenever, yesterday you didn't attend it, huh?
Yeah, attended.
Whenever you are creating any node, how many fields are there? Two fields. One is a data field, another one is a pointer pointing to the next node. But while creating a node object, you don't know who is its next field, right?
Yes.
That's why it is null. And whatever value that you are giving, with that value you will create a node. Clear?
Yes, sir. Thank you.
Yeah, right. Sir, everyone clear up to this? Now just I created one node. Tell me what is the content of that node just now I created. Let it be 10. What is the next node? Let us consider this is nothing but the next node what we have. So what is the next node? Let us consider. So the next node is nothing but this one what we have, like this. So next field is null. Can I say this is the tail? Yes. This is nothing but head. Now, can you please confirm it is available at 0th location, first location, second location? Am I right, friends?
Yes, sir.
Yes.
Now,
Yes, sir.
let me take one more example. Sir, I want to insert a node. Please observe this example. Maybe half an hour we are going to spend only on this. Assume that I want to insert a new node. Can I say it is a new node? Yes. Assume the data is nothing but 5. So next field is null. Where I want to insert in 0th location. Can I say 0th location means in front of this, correct?
Yes, sir.
Yes, sir.
Now see the instructions. What is the first instruction that we have? New node dot next is equal to head. Sir, new node is 5. Its next node is pointing to where? Head pointer. Then after that, head is equal to new node. From now onwards, this one will become head. Once if you come out from this, these duplicate references will be gone. Can I say now it is 0th location, it is a first location, it is a second location, it is the third location. Clear, friends?
Yes, sir.
Everyone got the point?
Yes.
Suppose consider my requirement is case is not 0, sir. I don't want to insert at 0th location. Sir, I want to assume that the list is empty. So one special case I am considering. What is the case is? So case if if we have only one element, if you have only one element, so assume I have one element is there, it is a fresh list. I have one element is there like 11. So I want to insert a new node. This is the new node that we created. Next field is nothing but what? Null. So before adding this, it is a completely new list, sir. It is a completely new list. Okay. So now what I'm going to do is, sir, once if you create a new node, immediately what will happen? we are incrementing the size by 1 unit. Now after creating this, previously size is 0, can I say now size is 1? Please confirm.
Yes, sir.
So assume that this is nothing but a head, this is nothing but a tail. Only one node is there. Got it?
Yes.
Yes, sir.
So now what is my requirement is, sir, I want to add at last location, sir. I want to add at last location. Okay, forget. I don't want to confuse you. Okay, let it be. Now see, in this particular program, I want to create a new node, but where I want to add these, sir, assume that the data is 40, next node is null, the name of the node is nothing but new node. I want to add this at the last index. Last index. Maybe I will count, but don't worry. Sir, last index means what will be the value, sir? So case
Index
if
4.
you want to, so if index is last, last means what?
Size minus 1.
3, right? Correct, huh? If index is equal to 3, correct, sir, in this example, am I right?
Yes.
Right, sir.
But we should not write 3, right? We have to write a code. Tell me, sir, if you want to get 3, what is the size of the node? As of now, up to this, it is nothing but 4, correct, huh? But
Yes,
this
sir.
node, after creating this node, we are incrementing, right? It will become 5. Am I right?
Yes, sir.
Now from
Sir.
5 to 3, how you will get? Can I take 5 minus 2? That's all. So whatever index that you are giving, if it is a size minus 2, then what is the meaning? I want to insert at last position. Are you clear with this?
Sure.
If you want one more example, listen carefully, friends. I have the elements from 0th location to 10th location. That means how many elements are there, sir? Please confirm. 11
11.
elements.
11.
Now
11.
I created one node. After creating one node, immediately this 11 will become 12, because here after immediate creation we are incrementing size. Got it?
Yes.
Yes.
Now at which index I want to add? If index is equal to 0, insert at first. If index is equal to 10, insert at last. Correct? Now I have given index is equal to 10. What is the size of the linked list? 12. 12 minus 2, is it a 10 or not? Yes, that means we are trying to insert at last location. Sir, you got this particular condition, right? Clear?
No, sir, actually, I'm still confused. But
Sir, assume again same example only I need to repeat. See, take this example. Yesterday I told very clearly, please refer this video minimum 1 or 2 times. Please focus. Again I am repeating. Step by step I am coming. So I am giving index value as a 3, sir. I want to insert at third location. But where this third location is there, we don't know, right? As of now, we covered only one case. What is that case? If index is equal to 0, I want to add at first location. But if I want to add at last location, there is only one line code is there. What is that code? First of all, tell me whether it is reached last location or not. So index is equal to 3. In my point of view, index is equal to 3. But in coding point of view, that is the last index. Correct? Who is asked this doubt? Please respond. Clear?
yes, 3 is the last index.
I want to insert at third index. But now my question is, total how many elements are there? As of now, 4 elements are there.
Yes.
Now I am creating one new node. Assume that that node content is 40. Next node is null. So new node, name of this node is new node. After creating this line, immediately what we are doing?
Correct. We are implementing the size.
That means the size will become what?
5.
5. But this is not yet linked. But we incremented the size. Clear? Now, what is
Yes.
the first case? Is index is equal to 0? No. Now we have to check whether you are trying to add at the last location. Sir, how to check last location? Whatever index that you have given, if it is equal to, what is the size? 5. 5 minus 2. That means last before element. This element will come here. If index is last before, because why I am taking minus 2, you got the clarity. Index value is always minus 1. But already one node got added, right? But link is not established. That's why minus 2. Clear?
Yes, sir.
Yeah. So now we have to link these two. Sir, what is the index that I want to add? 3. What is the size? 5. But it is not yet added, but already we incremented. That's why minus 2. Because if the indexes are 0 to 3, how many elements are there? 4. So 0 to 3, we added some new object. That means size is what? 5. Sir, how to get this index value? 5 minus 2, right? Because this newly added object, minus 1 for the index. Sir, clear everyone?
Sir, if we add the new node 40 at index 3, okay, then the node at index 3 will become in the node of index 4, right?
That we will see, sir. But you understood why I have written size minus 2.
Yeah. Okay.
Clear?
Okay. When you are inserting at last, then we are doing size minus 2 actually. Okay.
Yes, that's all.
Yeah.
Now, sir, tell me how we can connect. Can anyone tell me? You have this node name. 30 node name is nothing but what? Tail. 40 node name is nothing but what? New node. How to connect these two?
Tail to the new nodes.
Node.
Very good. Tail dot next is equal to what?
New node.
New node. That means these two are connected. Correct? Clear? Now, which is the tail node? 30 or 40?
40.
This 40
40.
right now.
Can I take like this? That's all. Clear, friends? Any
Sir,
questions?
Sir, I have a question here. I have still doubt over here. I'm not.
Sir, 1 minute. Sir, but we are adding in the 4th position as a.
Sir, seems to be it is like that. But actually, when you are inserting at 0th location, okay, is a 10 is moving towards beginning or ending?
Ending, sir.
Ending. But when you are adding at the last, that is my point, right?
Sir, but basically, we are trying to insert the node at index 3, right? We are not saying that we are inserting node at index 4. So if we are trying to index at 4, if the function is about if the method is about inserting the index at last, then I can understand it will come at 4th
Sir,
index.
actually, here this code is not required. Whatever code I have written, these two parts is not required. Why? Because can I say it is at insert at first? Can I say it is insert at last? But why
Yes,
I
sir.
included here is, if the index is 0, it is same like this, correct? If you take this example, if I am giving index is equal to 4, so I am considering, this is my implementation. You can change if you want. So what I am feeling is, sir, last index is 4. That means you are trying to insert at this position. Maybe positions may change. Are you understanding my point? If you want, you can customize. What is your point is, if I want to insert at 4th location, this 40 should come here. Whatever new node that you are adding, it should come at the 4th location. That is my next code. But why I have written here is I am treating like it is insert at first, insert at last. If you are giving before this, we are getting this message. After this, we are getting this message. So 0 means this is the code. Last index, if you are giving, it is something like insert at last. In the middle, what will happen? I will write. If you want, you can customize this. If you want, you can remove this also. Clear, sir?
Okay, sir, I'll close.
Yes, sir.
Sir, but we are sending the data and index number, but we are adding at 4, and but we are expecting it is before 30.
That's what, sir, I'm telling. In my point of view, it is if I'm giving at index 3, for example, consider this is my fresh list. Don't get confused. If you are confusing, just leave that function. So what is my point is different. What is my point is, now tell me, if I want to insert at a last location, this is my requirements. Okay.
According
Assume that
to
I
last,
want
it's fine, sir.
no,
I am
no.
able to.
That's what, sir. See, observe my point. I want to add at last. Tell me, if I want to add at last, the node 50 will come before 40 or after 40?
After 40, sir.
After 40. Clear? Now, my point is, if I want to do this by using this insert at location, what is the location you will give? I mean, index value that you will give to insert this 50 at the ending. You got my point? I want to insert the object 99 at the first. So I have two options. You can call insert at first. Clear? Can I call insert at location by giving index as 0?
Yes, sir.
Now same question for the last node. I want to add 50 at the last. We have two options. What is the first option? You can call add last method, that is insert at last. It is okay, already we implemented. Now with respect to index, I want to add this at last. Now suggest me, like index is equal to 0, what will be the index that you will suggest here?
Size -1.
Can I say
Size
size
-1.
minus 1 is 4 only, right?
Yes.
For insert at last, I get your point that it should be size -2 actually, because we are incrementing in the very beginning
No,
after
no,
creating
no,
node.
sir. No, sir. Don't come to code. Just example I am telling. See, you people are not following me, or I am not in a proper explanation mode. Okay, listen. Again, I am repeating one question. Please answer this question. First question is, see, I want to add one object called 99. Where I want to add? I want to add at the beginning. So I have two options are there. What is the first option? You can call insert at first. What is the second option? You have to give some index value. So by calling insert at location, what index you will suggest if I want to accommodate this 99 at the first node? Tell me.
0.
0.
0. Same rule we can apply for last node also, right? I want to add this 88 at the last. I have two options. One is insert at last we can call, which I discussed in the last session. Now my question, what index you will suggest so that this 88 should sit at the last? That is my question.
Size -1.
Tell only index, number, don't give any formulas. Number according to this example.
5.
4.
Can we give 5?
5.
No, sir.
Size -1.
How you can give 5? Is the 5 index is available? Are you getting the point?
Yes, sir. Why?
Insert at location or insert at index means what? That index should be there, right?
Yes, sir. But index is not there.
That's why 4. This is the special case. That means here it will add. This is only for insert at last case. Got it?
But sir, Okay, I got it. But when you are inserting at last, its actual index would be 5, right? After inserting.
After inserting, its value will become 5. My intention is also same, right? My node should be present at the last. See, once if you add that, size will change, index number also will get changed.
Sir, according to the index at location, for inserting at last, we should not use insert at location method at all. Because the index, if why would you try to
I understood. You are telling this method is not at all required, right?
inserting at last? For inserting at last, it is not required.
Yeah, but actually there is one problem. Actually, one student raised this question in our 2 to 3 batches before. That is the reason why I added this case. The reason is, see, they want to call insert at location, but I want to add at the last. Whatever question I raised for you, same question they asked. So for that only I have written this code. If you want, just ignore it. No problem. Clear? Can I go for next? Don't break your heads. Can I go for next?
Yeah.
Yes.
Sir, all these conditions are not there. I want to add one node. Sir, what is that node is something like, sir, 25. I want to add the node 25. Where I want to add this node? Sir, assume the index value for this is nothing but I want to add at third location. Tell me, in between which nodes we have to add this? Tell me the node content. In between which nodes we need to add this?
20 and 30.
20 and 30.
20 and 30, correct?
30.
So that means the value which is there at 33rd location will move to the next. Am I right?
Yeah.
Yes.
Can we go for coding now?
Yeah.
That is the last case that we have in this, okay?
Okay.
Yeah. Now observe carefully. Sir, what I am doing is, I have to break this link. I have to break this link. So here, I have to break this link and I need to add. Sir, how I am going to break? Let us see. I want to break this link. How I can, 1 second, sorry. 1 second. Sir, I want to break this link. How you can break? Sir, is there any name for 20?
No.
No.
sir.
We have only 3 names, correct? What are those 3 names? Head, tail, new node. But we don't have any name for 20. Am I right?
Yes, sir.
My first
Yes,
task
sir.
is I want to move to the 20. That is my first task. How I can move? Array, take one index. I is equal to 0. So take one temporary node which is pointing to where? Head. That means this is nothing but head as of now. Sorry, temp as of now. Sir, what I need to do? Move up to that location. Sir, while what is the condition? I will write that later. What you need to do? Temp is equal to temp dot next. And what you need to take? I plus plus. Now I is equal to 0. But better that I value whatever you have given is less than that index value or not, I am checking. So condition true, right? Just I have not written here. Just is that I value is less than the index value whatever you have given. Yes, true. That means what? Your temp will become this one and I value will become 1. Clear, friends?
Yes.
Now again, is I value is less than index? Yes. Can I move again temporary variable here? Yes. Then index value will become 2. Sir, up to this, any questions? Now we
No,
came
sir.
to the exact position, right? Correct?
Yes.
Can I write like 20 next field is 25? How you can write in the programming format? Temp next field is new node. Correct, friends?
Correct.
Can I stop the loop?
Yes.
But 2 less than 3, condition true, right? If I want to make it stop, what you need to take? Instead of 3, can I take 2? So I less than index minus 1. Can I take like this? Please confirm. So while
Yes.
the value of I is less than, what is the code index? Index minus 1. If you are clear with this, code completed. Any queries?
Mhm.
Clear?
Yes, sir.
One second.
So instead of traversing, we can directly go to the index, right, sir?
No.
Tell me.
So instead of traversing, we can directly go to the index, right, sir?
Where index concept is there, sir? We don't have, right?
So index minus 1, whatever is there, we can copy to the temp, and then we can find to the temp dot next is equal to new node like that.
Sir, you are asking index value is 3. 3 minus 1
Yeah,
is okay. In second location, you are telling you need to directly assign to temp, right?
correct, sir.
How you can copy or how you will get a second location element?
Oh, okay, sir. Okay,
It is not array, right? If it is array, we can take A of 2.
okay, sir.
Got it?
Yes, sir.
Sir, now you have to use your brains efficiently and tell me the code, how you can connect. Sir, how many links are there? 2 links, right? One is the connection between 20 to 25. Another one is the connection between
5 to 30.
25 to 30. But we don't have any name for 30. Again, I need to write a loop. Not required. We need to write in a technical manner. So that is logical thinking you need. Okay. Now tell me how we can.
New node dot next equal to temp dot next.
Tell me.
It's equal to new node.
Temp dot next is equal to new node.
New node.
Very good. Very good. That means temp dot next link will be gone and this one is connected to here. Clear? Now tell me how you will connect 25 and 30.
No, sir. Temp dot next. I think it will work.
Temp dot next
Dot next.
will become 40.
No, no, sir. We need to first
Very
check
good. We need to first connect which nodes? 25 and
new
30.
node.
Correct? How to connect 25 to 30? Tell me. New node dot
Dot
next
equal
is
to
equal to
temp dot next.
very good, very good. Temp dot next. Sir, who is temp 20? Next field of 20, 30. So 25, that is new node next field will become what? 30. Then tell me after that what you can take. New node dot, sorry, temp
Temp
dot
next
next
equal to
is equal to what?
new node.
New node. Now this node next field will become what? This one. So that this link will be gone, this name will be erased, this one will be gone. Clear, friends? Please confirm.
Yes, sir.
So if you want to understand this, Minimum 2 to 3 times you need to practice, otherwise you won't get. That's what I'm telling. Can we go for execution?
Yes, sir.
Yes, sir.
Now let me check how it is working. So in the main program we created a list. So list dot let me take insert last. I am giving 10, 20, 30, so 40 and 50. Now what is my requirement is list dot insert at a location. In 0th location I want to add 999. Let me check. Sir, added. Please check it.
Yes,
Yes.
sir.
Yeah.
I want to add at first location. Added.
Yes.
I want to add at the second location. Added. I want to add at the third location. Added. I want to add at fourth location. Clear? It is inserted last. Clear, friends?
Yes.
Now I want to add at the fifth location. Understood? So I want to add at the minus fifth location. Understood how it is functioning?
Sir, but
Yes.
when you are adding at fifth location, it's not adding. That is the only I'm not able to get it, sir.
No problem, sir. If you want, just skip that. No problem. Okay.
Okay.
Yeah. Clear, everyone? Then there are 2 more functionalities are there. Definitely I should complete this. Can I go for next? Easy only.
Yes, sir.
Okay.
Yes, sir.
Seems to be difficult, but very easy. So many questions are there on this in the lead code. Tell me what is the complexity of this. Don't see the code. Directly you can tell big O of n. Why? Because if you want to insert at 0th location, 1 unit. If you want to add in the middle, n by 2. If you want to add at the last, n. But always we will prefer worst case.
Yes.
Clear,
Yes.
friends?
Yes.
Everyone got the clarity?
Yes, sir.
Now, what is my next requirement is sorted insertion in ascending order. In ascending order. Sir, I want to insert the elements, but
Sir,
in
one
according.
question, sir.
Hmm.
Sir, for base cases, always big of n 1 then every
That
time.
is maximum that will be we go of 1 only. But sometimes in the books and all they are going to write big O of 1, but actually we need to take omega of 1. There is some mathematical theory is there, sir. Don't go in detail. It will confuse you. Okay.
Yeah, sir.
Clear, guys?
Yes.
Right. Now observe, friends. Sorted insertion in ascending order. Sir, I want to insert the objects, but while inserting, what it should do? In ascending order it has to insert. So insert or insertion in ascending order, like this I am taking. Just I will give only data, sir. What you need to do, you have to insert the data according to the order. Anyway, there is no limitation, right? Compulsory you should add. So I will create a new node with the data field, and the next field is nothing but what? Null, and the size I am going to increment. So at very beginning, I want to insert 25. So what will happen? A new node got created, sir. What is the name of this node? New node. Next field is null. Just I don't want to write. If you want, let me write next. Sir, head is what? Null. Tail is what? Null. Sir, first we have to check is head is equal to null. Tell me, sir, is head is equal to null or not?
Yes, sir.
Sir, can I say then head is equal to new node? And return the
Yes,
control.
sir.
Correct? Huh?
Yes, sir.
This one will become head. Sir, next point is very, very important. Up to this clear? Now,
Yes,
sir,
sir.
I want to insert a node. What is the node here is, assume the node is 20, sir. Tell me, we are not inserting at first or we are not inserting at last. We are not inserting at middle. We are inserting according to the ascending order. Now tell me where this 20 node should come. Before 25 or after 25?
Before 25.
Before 25. But it is something like insert at first. Correct?
Yes, sir.
Now, sir, head is equal to null. No, right?
No, sir.
So
But is this new node whatever you inserted should become head. Correct?
Yes, sir.
That's why what I am doing is I am writing one more code. What is that code? Array, whatever data you are inserting, is it less than head node dot data? Sir, whatever data you are inserting is what? 20. Is it less than head node data? Yes. That means whatever data you are inserting, whatever node you are inserting, it should be the head. But directly I can't take this one as a head, right? What you need to do? Sir, new node dot next field will become what? Head. Sir, what is the new node? 20. So 20 next field will become what? Head. After that, your head will become new node. Everyone understood?
Yes, sir.
Okay. Clear?
Yes, sir.
Yes, sir.
Now, sir, can I come from the beginning again? One more example.
yes, sir.
Now, observe carefully. Observe carefully. Sir, I am trying to insert a new node, sir. So what is that node is 5. 5. So what is the next pointer? Null, sir. What is the name of this node? New node. Sir, initially head is null. Yes. That means new node dot next is head. New node next field is what? Head only, right? That is null. Correct, sir? No problem. Am I right?
Yes, sir.
Then head will become what? New node. This is nothing but
New
what?
node.
New node. But because this is the first node, can I say it is also tail, right?
Yes, sir.
How you can do that? Directly we can't take because there are two conditions are there. That's why. So what I am doing here is after this, I will check one condition. If tail is equal to null, yes, tail is equal to null, then tail will become new node. Sir, now before assigning this, it is null only, right? That's why tail is equal to new node. Sir, if you are clear, one more node I will insert. Please confirm.
Yes, sir.
Now I am inserting one more node. What is that node? Is 3, sir. So we know clearly where this new node should come before head. So we are comparing. Is head is equal to null? No. The data which you want to insert is 3. Is it less than head node data? Yes.
Yes.
Now new node is there, right? What is its next field? Sir, new node next field will become what? Head node. Clear?
Yes.
Then head will become new node. Then tell me, sir, is the condition is satisfied? Tail is equal to null? No, right?
Yeah. No.
Yes, sir.
Can I say this one will execute only at very first time? Correct?
Yes, sir.
I think no need to go for any example. Clear up to this, everyone, please confirm.
Yes, sir.
Any doubts up to this? 1 second. Everyone clear? Can I go for next continuation? Please confirm. Sir, I want to insert one more node here. What is the node here is 7, sir. Next field is null. The name is new node. Tell me where this 7 should come.
After
After
5.
5.
After 5. So diagrammatically we are clear, but coding part. So what is the condition? Is head is equal to null? No, sir. Is the data which you are trying to insert is 7? Is it less than head node dot data? No, sir. That means it is not at first. Correct?
Yes, sir.
Now, sir, how we can connect these? For this, we need to write one explicit code. What is that code is? Observe, very simple code, sir. Node temp is equal to I am taking head. So this one will become what? Sir, temp. This one will become what? Temp. Now after this, what I am doing? Sir, until temp dot next is not equal to null. I am not checking temp. Temp dot next. Sir, who is a temp? 3. 3 next field is what? 5. Is it not equal to null? Yes. At the same time, so temp dot next, its data, is it less than the data whatever you are giving? Can you please cross check like that? So initially temp is 3, 3 next field is 5, so which is not equal to null, and temp is 3, its next field is 5, its data is nothing but 5. Is it less than the data that you are trying to insert? True, right? Please confirm.
Yes, sir. Yes, sir.
So then what will happen? Temp is equal to temp dot next. Now I am moving, sir, temp to 5. Now please cross check. Same condition. Temp dot next. Who is a temp? 5. 5 next field is null only, right?
Yes, sir.
While loop fail. Correct?
Yes, sir.
So now we have to connect which two nodes? Tell me which two nodes we have to connect now?
Temp and new node.
Temp and new node. Tell me how to write the code. New node dot or can I take temp dot next is equal to what?
New node.
New node. Now what is a temp? 5. 5 next node will become what? New node. Clear, friends, everyone?
Yes, sir.
Now one more code. Sir, we have to change the tail. Am I right?
Yes, sir.
How you can change? If new node dot next is equal to null, that means that is the last node. Then what you can do? Tail is equal to new node. Sir, what is the new node? 7. Is the 7 next field is null? Yes. That means this one will become tail. That's all. If you are clear, don't worry. I will take one more example. Clear up to this?
Yes, sir.
Now assume I'm going to insert one more node. What is that node is 6, sir. Tell me where this 6 should come.
After 5.
In between these two.
5 and 7.
Now see how the coding is going to work. Temp is equal to head. Okay. So temp is equal to head. Okay. Then temp dot next 5. Is it not equal to null? Yes. Temp dot next 5. Its data is 5. Is it less than 6? Yes. That means temp is equal to temp dot next. Now this one will become temp. What is the next line? Again, temp dot next not equal to null. Yes. Temp dot next data 7. Is it less than 6? No. That means loop fail. Clear, friends?
Yes, sir.
Now tell me, temp dot next, that is temp is 5. Its next field is directly, can I connect it to new node? No, right? So what is the line that you need to take? It seems to be the like previous code. What is the thing? New node dot next is equal to what? Array, new node dot next is equal to what?
Temp dot next.
Temp dot next. Don't tell tail, because in this example, luckily it is tail, but generally it won't be, right? Clear? Now, so
Yes, sir.
new node dot next. So new node dot next field will become what? Temp dot next. Okay. Then already code is there. Temp dot next is equal to new node. Then is new node dot next is null? No, sir. That means it is
Mm.
not a tail node. When this case will come, when you are inserting at last. That's all, connection established. So like that, what you need to do is try with the different examples, then only you will get clarity. Clear, everyone?
Yes, sir.
Clear, guys?
Yes,
Yes,
sir.
sir.
Right. So let us check really, is it working or not? So here what I am going to do is list dot. So sorted insertion in ascending order. I will give 10. So I will give 60. So then 10, then 40, then 20. So then 50. So then 30. I have given in different locations. I mean different numbers. You can see all the numbers are sorted according to the order.
Yes, sir.
Working fine, right? Sir, tell me, if I want to do this in descending order, what do you need to do? First of all, what is the time complexity for this?
Of
Of n.
Yes,
Now
sir.
tell me, if I want to do in descending order, what modification you need to do? Friends, please confirm. Sir, here in the place of less than, can I take greater than? Here also in the place of
Yes.
less than, greater than, except that remaining things are same. Correct, friends?
Yes.
Now let me check same example. Just the method name I am changing, friends. Now if you run, what is output? In the descending order, it should insert. Clear?
Yes, sir.
Yes, sir.
Right. Any queries up to this?
No, sir.
Any queries up to this? Please confirm.
No, sir.
Right. So practice up to this. Anyway, the remaining things I will continue in the next session.
Okay.
So in the last sessions, we are discussing about linked list. As a part of this, how to define node class, like how to define a node class, then constructor, how to get the size, is the list is empty or not. Next, and after that, insertion at first location, So after that, inserting at last, how to print the elements, toString method. So insert at a specified location, sorted insertion in ascending order, and also sorted insertion in descending order we discussed, like sorted insertion in ascending order. So next and after that, a sorted insertion in descending order. These things we covered very clearly in our last session. So now we have some extra methods are there. Let me talk about that. These are nothing but something related to display operation. Something related to display operation. So let us talk about that. See, generally, if we have any list is there, how we are going to display the elements? So one by one we can display. For example, consider I have a list with some elements like 10. The next node is nothing but 20, and the next node is nothing but 30. Okay, and the next node is nothing but 40. Like that we have. So next node is anyway null. Sir, this is head and this is a tail pointer. Sir, how to print the elements? What is the general way? Sir, display. It is nothing but a display version 1 by using loops. Sir, I am going to use loops to display these elements. Let me take the method name as a display 1. Sir, what is the first activity? If the value of head is equal to null, that means there is no more elements in the list. I am trying to print system.out.println of list is empty. Then return the control. Sir, my list is having some elements. How you can display now? Declare a temporary node which is pointing to head. And you know the loop, right? Until the value of temp is not equal to null, you are supposed to print the objects one by one. Like better to use print only. Sir, temp dot data I am taking, followed by some space. Sir, after that, temp is equal to temp dot next, and at last let me give system dot out dot println empty line. Let me traverse this. What output we will get in this case? Sir, very simple. Initially, temp is pointing to 10, sir. Is it not equal to null? Yes. Print its data, which is nothing but 10. Now, temp will become temp dot next. Sir, it is a while loop, right? Is a temp is not equal to null? Yes. Print its data. Now temp is equal to temp dot next. Sir, is temp is not equal to null? Yes. So print the data. Then temp is equal to temp dot next. Sir, is temp is not equal to null? Yes. Print its data. Now temp is equal to temp dot next. Sir, is a temp will become null or not? Yes, it will stop. So this is nothing but, of course, already we covered this concept. Same thing is there here. Any queries up to this? Clear?
Yes, sir.
Right. Sir, let me run this code. Okay, let me run this code. Sir, after this, I am taking list dot display 1. Display 1. Sir, is it displaying the same elements or not? Yes. Sir, now I don't want to use this iteration. I want to use recursion. So display version 2 by using recursion. Can you please use recursion to display? Sir, I am taking void display 2. But we know already recursion means what? Compulsory we have to take parameters. Based on the parameters only it is going to work. That's why I am taking some node temp. Sir, if the value of temp is equal to null, I am going to stop the process. Otherwise, try to print the data system.out.print of temp.data and followed by some space. After this, Again, I am calling display to by passing temp comma next. Don't worry, I will show you how it is going to work by taking the same example with a different color. Observe friends. So consider my temp is pointing here. I will pass this node as the input. Is a temp is equal to null? No sir. Print its data. Now what is the next method call? We are going to pass this one as the argument. So 10, 20, 30, 40 like that we will get. Sir, whenever your temp became null, what will happen? It will stop the process. If you want, you can check. Sir, I am taking display to. Is it going to give the same output or not? Sir, something is gone wrong because for display to what you need to do? Sir, list dot, you need to pass the head pointer. Now you will get. Sir, everyone understood the scenario?
Yes, sir.
Can you please tell me, is it a tail recursion or non-tail? Tail recursion, correct?
Tail.
Yes.
Tail recursion. Can I use the same story for non-tail also? Yes. So display version 3 by using recursion, but which recursion? Non-tail. So what I am going to do is very simple, sir. Display 3 non-tail means what? This SOP statements you need to take after the recursive call. Correct, sir?
Yes, sir.
Now let me take that display 3 as the parameter. Now see what is our expected output. It should
Reverse
print in
the
reverse direction, right? Sir, everyone understood the scenario? Sometimes in the interview they are going to ask, Are, can you please write a program to reverse the given linked list? So what you need to do? Just you have to write this display code. Clear, everyone?
Yes, sir.
Yes.
Friends, please confirm clear up to this.
Yes.
Sir, I have one query here. So,
Yeah, please.
so we have, I mean, linear search is always, search, sorry, recursion is not, it is not the ideal, right? For uh, loop is better than recursion, right? Uh,
Hmm.
Performance wise,
Yes,
it's,
yes,
yeah.
yes.
So we should go for loop, right? Instead of
Yes.
recursion.
Suppose if they are asking to print the linked list in the reverse direction, at that time loop won't work out, right? Correct?
Right. Yes.
So if you take loop also, what you need to do? So you have to take a loop till to reach the ending. Again, previous pointer won't be there here. Correct?
Right.
So which is a difficult challenge, but recursion is giving the facility, right?
Yes. Yeah.
So that's why there is some universal truth. If you want to get something, definitely we need to miss some features. For every advantage, there is some disadvantage also will be there in programming. Okay.
Right. Yes.
That's all, friends. These are nothing but the display versions what we have. I think in these three display versions, the first version already we covered in our regular syllabus. Okay. So, but just officially for documentation purpose, I explained these three. If you are clear with this, like this, we have one more operation like a searching. I will explain about that. Up to this clear?
Yes.
Yes, sir.
Right. So now let me add this here in the documentation. So what is that? Display version 1. So display version 2. Display version 3. So next I'm going to talk about search operation. I want to talk about search operation. Sir, I want to search for an element. This is nothing but my requirement. So let me take that search operation. So search version 1. So here I'm going to use iteration, that means a loop. And what is the return type? It is going to return a Boolean value. So Boolean search one, which is going to take integer data. Sir, I want to search for this data. You know the logic, right? I think no need to draw any diagram. First, initially, we are going to make a pointer to point to the head node, and we will check is that node is not equal to null, means every time we are checking is the data of the node is matched with our data. If it is matched, what we will do? Sir, we will return true saying the data is available. Sir, I traversed the total nodes, but I didn't got that. Then what we have to do? Return false. Is it correct, friends?
Yes.
And I forgot to add one more point. Sir, temp is equal to temp dot next. To control the loop, you need to add this. So I hope no need to worry about these things. Clear?
After
Yes, sir.
okay, that's
Right. Sir, next same search operation version 2 by using iteration only, but I don't want to return Boolean value. I want to return the location where it is available. So integer data. How you can able to do? Sir, first node temp is equal to, I am taking head and I will start analyzing from the 0th location until the value of temp is not equal to null. What you will do, sir? If the value of temp dot data is equal to data, I am going to return which value? I value. Then temp is equal to temp dot next and I plus plus. And at last what we are going to do? So we will return -1. Clear, friends?
Then we are not returning I.
We are going to return I. Why? Because see, suppose if I am searching for 40, what will happen? I is equal to initially 0, temp will be pointing here. So the data is not matched. Now temp is equal to temp dot next and also I value will be incremented. Now temp is this one, I value is incremented. Now temp is this one, I value is incremented. That means what? Matched, right? So the data is available in which location? Third location. Got
Yes.
it?
Yes.
Sir, everyone feeling comfortable?
Yes.
Yes, sir.
Now let me check really is it working or not. System.out.println. So list dot search one of, I am going to search for 40 and I am searching for 400. So these two I will repeat for search 2 also. So one is going to return true or false, another one is going to return the location, and then if it is not there, -1. Are you clear with these two versions? Please confirm.
yes.
Yes, sir.
Yes, sir.
Now, sir, I want to implement these two by using recursion. Sir, if I want to use recursion, we know the thumb rule, right? What is the thumb rule that we have? Sir, search version 3 by using recursion. But my return type should be Boolean. I hope you can understand this. So Boolean search 3 I am taking, where we have to pass a temp at the same time data. Sir, what is the base condition? If the value of temp is null, at last it will come. Then I am going to return false. Otherwise, every time try to compare the data with the data. Sir, if it is matched, what value we have to return? True, so that it will terminate. Otherwise, can you please call this a search 3 by passing temp dot next comma data? Do you need any explanation for this, Anna? Please confirm. Clear?
Yes, sir.
Sir, why we are why we are using first argument no temp?
So because in the recursion I told, if you want to do recursion, that stack space is there, right? Inside the stack they need to store the parameters, then only what is the next call, like that they can trace. Okay, sir, clear everyone? Now sir, if I want to implement the same search version 4 by using recursion, but my return type should be integer, sir, can I take a search for by passing node comma temp integer data? In addition to that, I will give index also. So if temp is equal to null, tell me sir, which value I have to return? Anyone guide me? If temp is equal to null means a search is successful or unsuccessful?
So minus
Very good.
Successful.
We have to return which value?
minus
Minus 1.
1.
-1.
Then so if temp dot data is equal to data, which value we have to return?
1.
Huh?
Index.
Index. But I will give index plus 1. Why means you will get clarity soon. Otherwise, what I am doing? I am calling same search for by passing temp dot next comma data field comma index plus 1. Now observe, sir, while calling, what I will do is, so what is the temp? Initially the node is a 10, the data which I want to search is nothing but 30. Index value, can I give 0? No, right? So I am going to give this value as a -1 while calling. Now observe, sir, temp is nothing but what? This one. Sir, is a temp is equal to null? No. Is a temp dot data is equal to the data? No. Then we are passing temp dot next and same data I am passing, like sir, 20 next call will be, so 30 -1 plus 1, which will become 0. Now it will come here. Sir, is the data is matched? No. Then again temp will come here. So that means 30. So 30, 0 plus 1, 1. Now the data is matched. Return index plus 1. Index value is 1. 1 plus 1 means 2. So 0, 1, second location. Got it, friends?
Yes, sir.
So at the time of passing, what you need to do? Search 3, search 3. So search 4, search 4. At the time of passing, so you have to give list dot head as the parameter. So then the data which you want to search and -1. So here also list dot head, so comma 400 comma -1. And here also, so we need to pass a list dot head comma 40. So here also list dot head comma 400. That's all. Now is it going to work? Definitely it will work. Sir, are you comfortable with the search operations? Please confirm.
Sir, index y -1.
Sir, at very beginning, can I give 0? No, right? Is it present at 0th location or not? Until verifying this condition, I don't know, right? Then I can't start from 0, right? If I start from 0, what is the meaning? You are giving a clear conclusion that in the 0th location, the data is there, correct?
Yes, sir.
Because without checking how I can give, that's why let it be -1. Because return type is integer only, right? If the data is not available, then default value will be there. Understood, sir?
Yes, sir.
Sir, everyone, please confirm. Is this search operations are clear?
Yes.
Yes, sir.
But sir, just one query here. So the search operation using recursion, client will never be able to call this, right?
Sir, client?
Yeah, I mean
No. See, whenever you are writing the driver code, there you will manipulate. Suppose if the client is required to search for some student details, you will provide input only the student hall ticket number. At the time of clicking, whatever data the user has given, From that, you need to call the procedure. Are you getting?
Okay.
So at the time, you need to pass the additional parameters manually because it won't change, right?
Right.
So which is going to change? That key which you are searching, only that will be changed. Remaining things are fixed, right? Sir, everyone clear? Can I go for the next method? Another two easy methods are there. After that, we will go for delete operation, which is very, very important. Sir, clear?
Yes. Yes.
Yes.
Right. At any cost, maximum, at least we need to finish 70 to 80% of the single linked list. Sir, next one, it's a very easy and interesting also. Some majority of the times they asked this question. Sir, why you are taking rounds instead of square boxes? Just for my easy understanding and drawing purpose, I am drawing like this. Don't get confused, both are same. Okay. Sir, now I have some data like this 30. So next node is 32. So next node is 75, like that we have. And the last node what we have is nothing but null. So this is nothing but a head node, and this is nothing but the tail node what I have. Now observe friends, what is my requirement? I want to find out nth node from the beginning. Like I want to return the data. So nth node from begin. Sorry, if I am giving the value of n as 5 or n value of n as a 4. Sir, first node, second node, third node, fourth node. What is its data? 32 I have to return. Sir, is the concept is clear?
Yes, sir.
Suppose if the value which you have given is less than 1, that means 0th node, that terminology is not allowed. Even if it is greater than the size also, I am going to return -1, indicating that it is invalid data. Otherwise, let us declare count is equal to 0. So node as usual temp is equal to head. So my pointer is pointing here, which is nothing but so temporary node. And what is the count value? Sir, count value is initially 0. Now we have to check while is the temp is not equal to null. Yes, sir. It is not equal to null. And can you please cross check is that a count value is less than n minus 1? What is a count value? 0. Sir, is it less than? What is the n value that you have given? 4 minus 1, 3. Sir, yes. That means what? You have to do two operations. One is a temp is equal to temp dot next. At the same time, count plus plus. Now temp is pointing here. Count will become 1. Sir, is temp is not equal to null? Yes. Is count is less than this one? Yes. Now temp will become here and the count value is 2. Temp is not equal to null. 2 is less than 3, condition true. Now temp will become here and 3 is less than 3, condition is fail. It will come out from the loop. Sir, can I return the temp dot data? Yes. Return temp dot data. Sir, sometimes there may be a chance if it is reached to the last null. Can I ask on the null data? No. That's why when it is happening, if temp is not equal to null, just to avoid null pointer exception, I am adding this. Sir, otherwise, if null pointer came, then return -1. Sir, everyone understood?
Sir, here is a zeroth node is also we can
No, no,
consider.
no. I'm not talking about the index. I'm counting from 1. First node, second node, like that.
Okay.
So if you take count 0th node like that, what you need to do? One value you have to reduce, that's all. Got it?
Yes, sir.
C
So
less than
also,
n, if you take, it will sufficient.
yeah.
Clear, friends? So what is the next one is Sir, nth node from ending. Nth node from ending. Sir, I want to get nth node from the ending. Tell me, is there any reverse pointer, sir? Do you have any reverse pointer here?
Tell.
No, right? Sir, observe carefully. Observe carefully. One small logic is there, friends. See, I am asking second node from the ending. What is its value, sir? 32 only, right?
32.
Sir, now what is the total size of the linked list? How many elements are there?
5.
5.
5.
5. Sir, 5 minus which node you need from last? 2 plus 1. Observe, 6 minus 2, 4. Can I say is it the from beginning? So from ending, if I want this node, what you need to do? Sir, you need to find out the total size minus here how many elements you came, that if you subtract, so you will move in the forward direction, correct?
Yes.
Yes.
Are you getting the logic? So instead of writing again code, what I will do? Can I call same nth node from begin function? What will be the parameter? What is the size of the list? Minus 1, sorry, size of the list minus n plus 1, correct, sir?
Yes, sir.
Because sir, in this example, total we have 5 nodes are there. Sir, last one node, if you want, it is nothing but fifth node from the beginning, correct? So what is the size? 5. 5 minus 1 means what? 4. 4 plus 1 means what? Fifth. Like that I am getting. So let me run this code and check whether it is working or not. Sir, I am going to call list dot nth node from the beginning. I will start giving from 1, sir. 1, 2, 3. Let me give nth node from the ending. First node from the ending. Second node from the ending. So 100th node from the ending. Now see. First node from the beginning. Second node. Third node. Last from the last. First node. Second node. 100th node. This is the way how you can calculate nth node from the beginning and nth node from the ending. Do you have any queries up to this?
Yes, sir.
Nth node from the end this is the only logic available, or there is any other logic?
As of now, this is the only logic, sir. Why? Because see, you can't come back. That is the problem with the single linked list, right?
Yes.
So you can move only in one direction. That is the biggest problem what we have. Then how to come backward? Not possible, right?
Got it.
That's why this is the only logic. Suppose if you have double linked list, easily with less code we can write.
Got the point. Because my question is like now we have 100 nodes. I need to come back from the end. I need to come back 2 nodes. I need to again.
That
I need
means
to
you
go
need to
from
travel
28.
98 nodes.
98.
Yeah, that is a problem. That's what I told. Suppose if you have a reverse link, that is previous pointer, so it will be very easy.
Got it.
See, I am not explaining this nth node from the beginning and ending in the double linked list. What you need to do is you have to practice, because if I take linked list 3 to 4 months I will take, but that is not our curriculum, right? That's why you need to practice more. Got it?
Got it.
See, maybe 1 or 2 times you may fail, but you need to keep on continuously try at least one operation. That's all.
Sure.
Yeah. Can I go for the next major operations? Easy part only I covered in today's session as of now. Can I go for the major part?
Yes, sir.
Right. So everyone, please present in the class because an important topic we are discussing now. See, the next operation is, sir, can you please delete the element present at the first location? The method name I will take like delete at first. See, to understand this, first I will create one linked list. So let us take, this is nothing but my linked list, which is having a nodes like this. So this is nothing but a 10. So 11. Okay, next 12. So 14 and then 19. And this is nothing but a null. And there is a link. And there is a link. And there is a link. And there is a link like that. Sir, this is nothing but a head. So this is nothing but a tail pointer what we have. Sir, now I want to delete the first location element. When we can't delete, sir, if head is equal to null, I can't delete, because if head is equal to null means what? The list is empty. I am printing list is empty. Return the control. Are you clear with the first case?
Yes.
Now tell me, friends, there is one more case. If head dot next is equal to null means what is the meaning? Anyone?
One element.
Very good. The list contain how many elements?
One element.
Only one element. Sir, if I delete that element, what will happen? Your list will become empty, right?
Yes.
Correct. If head dot next is equal to null means what? We have only one element is there. In such cases, head is equal to tail is equal to, I am assigning null. Sir, after deleting, compulsory size minus minus and return. Are you clear with these two cases? One is if the list is empty. Second one is if your list having only one element. Got it, friends?
Yes, sir. Yes, sir.
Now, sir, my list is having multiple elements. What you need to do? No problem. First decrease the size. After that, sir, can I take head is equal to head dot next? Simple step, correct? Now this is not head. This one will become head. Anyway, we will always move from the head. So this one by default removed. Clear, guys?
Yes, sir.
Now let me check. Let me check.
Sir,
Sir.
first we have to display the size. It's a good way because it will lost after
No,
deleting. We can.
no, not required. Just our main intention is to concentrate on the logical part, sir. So if you want, we can. Okay.
Yes, sir.
Now,
For
see,
first, we need not to take temp variable, right, sir? Because it is first, so we
yeah,
can
it is a
directly move
first,
the
right? Directly from that, we
Yeah.
can move to the next. That's why. Okay. Now, sir, I'm not adding anything. Okay, my list is actually empty list. Sir, from that, I'm going to call which operation, sir? Delete. Delete operation I'm calling. So list dot delete at first. My list is empty. How you can call, sir? My list is empty. Now I am taking a list which contains only one element. Okay, only one element. Let it be 100. Only one object is there. Now what will happen? Sir, 100 and that object got removed. Sir, now like this I have, sir, 100. So 200, 300, 400, sir, 500, 600, like that we have. Are you seeing the object which is available at the first got removed? Do you have any queries up to this?
No.
No, sir.
Right. Sir, now I want to delete at last. Sir, whether you are deleting at first or last, some primary conditions will be same. What is that primary conditions? If the list is empty, if head is equal to null, then we can't delete. Let me rewrite the diagram like this only. Sir, now is head is equal to null? No. If your list is having only one element, this is the case. Otherwise, anyway, size minus minus, you can't touch head, right? Now, which node we have to remove, sir? Tail, right? Please confirm.
Yes, sir.
Can I remove that tail
Yes,
node
sir.
directly? Yes, but you have to do one operation. Sir, before deleting the node 19, who is the tail? 14. That pointer assignment you need to do. Otherwise, you can't. Correct, sir? Am I right? See, if I want to delete the node 19, we can directly delete. How? Because that is the name is there, right? But what is the problem? Sir, who is the tail node after deleting 19? 14, right? So how you have to give name for that, right? Anyway, we
Yes,
can't
sir.
come back. Just now I discussed it. Sir, got the point?
Yes, sir.
Now what you need to do? You have to take one temporary variable which should move up to
Travel up
which
to
node?
14.
14. But I will take two pointers. Why? Means you will get clarity. Node temp1 is equal to head. Node temp2 is equal to head dot next. Two pointers. Sir, now listen carefully. This is a temp1. This is a temp2. Like that I have taken. What is the condition? Until temp2 dot next is not equal to null. Sir, temp2 means what? 11. Is next field is not equal to null? Yes. Then temp1 is equal to, sir, temp1 dot next, temp2 is equal to temp2 dot next. That means what? Sir, this one will become temp2. This one will become temp1. Is temp1 next field is not equal to null? Yes. That means this one will become temp1. So this one will become temp2. Sir, is temp2 next field is not equal to null? Yes. That means this one will become temp2. This one will become temp1. Is temp2 next field is not equal to null? No, it is equal to null. It will stop. Sir, now I have a pointer on this node. I have a pointer on this node. Clear, friends? Clear?
Yes, sir.
Now tell me, what is a code that I can take? Can I take temp1 dot next is equal to what? Null. After doing this, which is the tail? Temp1. Are you clear with this? So
Yes.
temp1 dot next field will become what? Null. This one will become what? Tail node. Everyone understood, sir? Clear? Now let me check really is it working or not. Instead of delete first, let me take delete last and check whether really is it deleting or not. Is the last node is deleted or not? Yes. Friends, please confirm everyone. Are you comfortable up to this?
Yes, sir.
Sir, delete at first, okay. Delete at last, okay. Then what you need to write? Delete at? Delete at?
Yes.
Yeah,
Location. Sir, I want to delete from a particular location, sir. How you can delete? How you can delete? Sir, delete from location. So what you need to do here? Sir, I'm going to declare void delete at location. I will give the index value, sir. You need to delete. Suppose if head is equal to null, what is the meaning? Sir, system dot out dot println of list is empty. I can't delete. Come out. One more case. Sir, whatever index that you have given less than 0 or the index value is greater than or equal to size. Sir, then what will happen? The range which you have given is not available. I am printing out of range. So come out from that. Sir, otherwise if the value of index is equal to 0, sir, array already we have delete at first method is there, right? Can you please call that? Sir, if index value is equal to size minus 1, array we have delete at last is there, right? Call that one. Up to these 4 cases, do you have any queries?
No, sir.
Clear?
Yes, sir.
Yes, sir.
Right. Now observe, friends, we have to write our main logic now. Better I will take that diagram as it is, like this. Sir, what about locations? 0th location, first location, second, third, and then fourth. Assume I want to delete the element present at location 3, sir. This is my requirement. How to write main logic for that? Sir, we need to traverse, right? So that's why I is equal to 0. And node temp, what is the initial value of temp head until temp dot next is not equal to null? At the same time, your I value is less than index, means you need to do 2 operations. What is that? Temp is equal to temp dot next and then I plus plus. Okay, but before that I will check one more condition. Later I will write code. What is that condition? Sir, can you please cross check is I value is index minus 1? Now observe, what is the initial value of I, sir? I value is nothing but 0. This is a temp. Is a temp dot next not equal to null? Yes. Is I value is less than the index location whatever you have given? Yes. Sir, is I value is equal to index minus 1? No. Then temp is equal to temp dot next, I value will become 1. Next time, is next field is not equal to null? Yes. Is it less than the index? Yes. Is it equal to index minus 1? No. Then temp is equal to temp dot next, index value will become increment. Is 2 is less than 3? Yes. Sir, is 2 is equal to 2? Yes. That means we came to the pointer where the next node after this one we need to delete. Sir, I got target, we have to delete now. Sir, where we need to write code? Here we have to write code. Sir, up to this any questions?
No, sir.
Sir, only 3 steps I am doing here. What is the 3 steps is just I am connecting these two, sir. How I can connect? Sir, what is the temporary node? 12. What is its next node? 14. What is its next node? 19. That one will become, sir, temp dot next. Temp dot next is equal to temp dot next dot next. After that, we deleted that link size minus minus and come out from the method. Are you clear, friends, up to this? Please confirm. Sir, you got the logic right?
Yes, sir.
Now, sir, can you please run the show and show me? Really, is it working? So let me take list dot delete at a location. I am giving 0, or let me give minus 9. What will happen, sir? Out of range. Sir, let me give here 0. Sir, is it calling delete at beginning? Yes. Let me give 1. Yes, 200 got deleted. 0, 1, 2, 3. Let me give 3. Is 400 is deleted or not? Let me cross check. Yes. 0, 1, 2, 3, 4, 5 I am giving. Sir, is that 600 got deleted or not? Let me check. Yes. Sir, now try to give 6. Is that sixth location is there? No, right? Out of range. Friends, clear up to this?
Yes.
Any questions?
Delete all means we need to make head and tail equal to null.
No, that's all. Delete all means head is equal to tail is equal to null directly. Okay, na?
Yes.
Yes.
Sir, in the while loop,
Hmm.
return is there, na?
Sir?
In while loop, return at the last return is there, na, sir? Whether it returning only one value or whole data list.
No, we are not returning anything here. The function return type is void. But why I am using explicitly return to come out from the loop? That's all. There are
Yeah.
two places where loop is going to exit. One is once if the condition got satisfied. What is the second one? If we got the result. Okay.
Sir, for delete all, we should do head and tail both to null, right?
Yes. Head is equal to null, tail is equal to null, size is equal to 0, return. That's all.
Right.
Now, sir, there are two more cases here, that is delete operation. What is that is, sir, delete first means it will delete the first object. Delete last means last object. It won't see the content. Delete at location means it will delete from the location. But my requirement is I want to delete the element. So void delete element I am taking. I am going to give the data. Can you please search for this data? If the data came, then delete. Now take the same example. I will show you how you can able to delete. Sir, now I have not given any index. Sir, is index is going to play any role here now? No. Assume that the data which I have given is 12. I want to delete this at 12. Sir, what you need to do? If your head is equal to null, whether you are doing deleting the data or not, first of all, my list is empty. Like this, I will display. Now, what is the second case? Sir, whatever data that you are going to delete, it is available at first location. That means what? Head data data is matched with our data. Is the condition is clear? Correct.
Yes, sir.
Yes, sir.
Then what you need to do, sir?
So
Head is
delete
equal to
Equal to null. Null.
head dot next, right?
Okay.
Clear. But there is some problem. Assume I have only one node is there. This is head and this is a tail. The content is 12. I want to delete 12. Sir, head dot data matched, right? Correct. Now what is the next node of 12? Null. So we are assigning head is equal to null. What about tail? That's why if you have only one node, how you know, sir? After taking these, if head is equal to null, what is the meaning? We have only one node. In such a case, tail is also null. Then size minus minus come out. Sir, clear up to this? Hello guys, please confirm. Clear?
Yes, sir.
Now, sir, my list is not empty.
Sir, but if but we are not Just assigning the head is equal to null, no, sir?
No, sir.
If
See,
one data,
if you have only one data is there, this is my head node. This is
yes,
my
sir.
tail node. Content is 10. I want to delete 10. Then what will happen? Head dot data is equal to data. Head is equal to head dot next. What is the next node to head? Null, right? So head will become null. So who will assign tail also null? Got it?
Oh, yes, sir. Okay. Got
That's
it.
why. That's why. But when we can say it is only one node is there, after assigning head is equal to head dot next, if head become null, that means there is no node. In such a case only we have to assign tail is equal to null. Clear?
But here tail also automatically should become null, na, sir. Why
Sir,
we explicitly
how, sir?
define?
How? Suppose consider in this example, I want to delete 10. Is my head dot data is equal to data, right? Then head
Yes.
will become head dot next. If I write tail also null, then what will happen? Dummy, right? When I can write this line, when you have only one node, that node is also matched the data. Got it?
Yes, sir. Good.
Sir, all these conditions are not satisfied. That means the node is available somewhere in the middle. We have to write the main logic. How you can write? Array, take some temporary variable pointing to head. Move on this until temp dot next is not equal to null. Sir, while moving, two steps. One is a temp is equal to temp dot next. What is another step? Array, can you please cross check is the next field data is matched with the data. That's all. Now observe, this is initially temp. Is next field is not equal to null? Yes. Is its data matched with the data? No. Then temp is equal to temp dot next. Sir, is temp dot next is not equal to null? Yes. Is the data is matched? No. I mean next field data? No. Then, sorry, next field data matched, right? Correct, sir?
Yes, sir.
So that means it will stop. I got this pointer. From here, I am going to delete this at 12. Sir, up to this clear? Please confirm.
Yes, sir.
Tell me, what is a code? Temp dot next is equal to what?
Temp dot next.
That means this link. Correct? Huh?
Yes, sir.
Any questions? Sir, after this, what is the two more lines? Size minus return. Clear?
Yes.
But there is one small problem. What is that problem is? Listen carefully. See, assume I want to delete, okay, I want to delete the node 19, sir. This is a temp, next not equal to null. So temp next not equal to null, temp next not equal to null, temp next not equal to null, but temp dot next data matched. Now what is the instruction? Sir, temp dot next is equal to temp dot next dot next. That means what? It should be null. Correct, sir?
Yes, sir.
At the time, who is the tail? Please tell me. Which node should become tail? Temp, right?
Temp dot next.
Temp, right? 14. 14 is the tail, right? How you can check that? Can I take if temp dot next is equal to null means what? We came to the last. In such cases, the temp will become tail. Got it? When it will happen? When you are deleting the last node. Clear?
Yes, sir.
Everyone feeling comfortable up to this?
Yes.
Yes, sir.
Right. Now let me check really is it working or not. Sir, I am giving insert at last 100, 200. So 300. I want to delete the element. So delete element of something like 400. Now check, is the 400 got removed? Is it removed?
Yes, sir.
Sir, if I am giving 600 also, let me check whether it is working or not. Is it working? Is it working or not?
Yes, sir.
But my question is, after removing this, I want to check list dot head dot data plus some tab space list dot tail dot data. I want to check. So before deleting, after deleting. Now have a look once. Sir, head dot data is 100, tail dot data is 600. After deleting, head dot data is 100, tail dot data is 500. Clear, friends? Suppose if I am not writing these two lines, see what will happen. If I am not writing these two lines, sir, what will happen? Observe. Anyway, the data got deleted, but last node data is already available, right? Even though the node got deleted, one pointer is pointing. Sir, are you understanding the point?
Yes, sir.
Any questions? Any questions? Now observe, sir, I have 100, 200, so 300, 200, 500, 200. So now I have 600 like this. Okay. Now I want to remove 200, sir. Tell me, is it going to remove that? How many occurrences it will remove, sir? Let me
First
check.
one.
Only first
First
occurrence,
one.
correct?
Yes.
Remaining occurrences are there. Sir, I want to delete remaining occurrences also. Tell me what you need to do. Is the method is same? Yes. One small modification. One small modification. Sir, what is that modification is? Sir, here whenever the element came, we are coming out, right? Am I right?
Yes,
I am
sir.
removing that. If I remove, what will happen? It will again continue. Am I right?
It will go to the last.
But one more thing we need to check. Sir, until temp dot next is not equal to null, then only we can take a temp is equal to temp dot next. Otherwise, what will happen? Null pointer exception may come. Now run the code. Sir, is it removing all the occurrences? No. Why? Because the method name we changed, delete elements. Now is it removing all the occurrences? Please confirm.
Yes, sir.
Clear? Tell me, what are the operations that we covered? Delete at first, then delete at last, next delete at location, so next delete element, so next delete elements, next nth node from begin, then nth node from end. These are the 25 operations what we covered as of now. Any queries? In the last videos, we started about single linked list. As a part of this single linked list, I explained very clearly almost 25 operations on single linked list, like how to insert, how to display, how to search, all these things. So now we have few more important operations are there. Let me talk about that. What are those operations are? Sir, the first one, I want to remove. Okay, I want to remove duplicate objects. Okay, I want to remove duplicates. Sir, from a linked list. But is it possible to remove the duplicates? Actually, there is a lengthy code. But here I am explaining, if the list is in sorted order, then only we can remove the duplicates easily. Sir, how? Let me take one example and I will demonstrate. So to understand this, let us consider a list with some elements like 10. Sir, the next node is nothing but 20. If there is any duplicate next, if you sort the list, it will be 20 only, right? Sir, next element is also what? 20 only. Sir, next element is a 20. Sir, next element is a 30. What is the next element? Next element is a null. Sir, this is nothing but a tail. This is nothing but a head. What is your task? Your task is to remove all these duplicates. But how to do that? Don't worry, I'm going to take example now. Sir, for this, I'm taking a method like remove duplicates. Sir, is there any input for this? No, just we need to write the code. Sir, is the skeleton is clear? Is the skeleton is clear? Please
Yes, sir.
confirm.
Yes, sir.
Now, sir, how to do
Okay.
that? I am taking one temporary node pointer which is pointing to head. Sir, this is nothing but a temporary node which is pointing to head node. After this, I am checking one condition. What is that condition? Sir, until temp is not equal to null. Sir, I am doing two operations. If temp dot next is not equal to null, at the same time, temp dot data is double equal to temp dot next dot data. Then one operation. Otherwise, simply temp is equal to temp dot next. Sir, initially, what is the value of temp? Sir, initially, what is the value of temp? Sir, it is pointing to the head node. Sir, is the next field is not equal to null? Yes. Is the current node data and next node data both are same? No. That means temp will become temp dot next. Sir, is temp is not equal to null? Yes. Temp dot next not equal to null. But temp dot data and temp dot next data both are same. Now what you have to do? You need to remove this node and you have to attach these two. Am I right, friends? Please confirm.
Yeah.
Now, sir, can I write like temp dot next is equal to temp dot next dot next? After this, one node got removed, right? Size minus minus. Clear, friends? Please confirm. Is it clear?
Yes, sir.
Now what will
Yes,
happen?
sir.
Since it is a loop, one more time it will repeat. Is temp 20? Is it not equal to null? Yes. Its next field is also this one, not equal to null. Is this data and this data same? Yes. Then temp dot next field will become what? Temp dot next. So that this node also removed. Then again what will happen? Sir, temp is not equal to null. Temp dot next, this one not equal to null. This data and this data both are same. Now this link also got removed. Sir, now what will happen? Is temp is not equal to null? Yes. Temp dot next? Yes. Is this data and this data same? No, it will come out. Temp is equal to temp dot next. Now temp will become what? 30. Is temp is not equal to null? Yes. Is temp dot next is not equal to null? No. That means if condition is going to be failed. Now temp is equal to temp dot next. Is temp is null, right? It will stop. Got it, everyone?
Yes, sir.
Sir, clear?
Yes, sir. Yes.
Yes, sir.
there is one more add-on you need to take. What is that is, see, by mistake, if a temp dot next is double equal to null, then you have to update the tail. Suppose if you are deleting the last node also, just this is the condition. That's all. This is nothing but how to remove, okay, how to remove duplicates from list. Any queries up to this? Any queries
Sir,
up to this?
So
No,
what
sir.
if the list is not sorted?
So if list is not sorted, you can't do this. What you need to do, you have to sort the list and then do. How to do the sorting, sir? Sorting list. Actually, it is not there because you asked, that's why I'm explaining. Sir, sorting a list. How you can sort? SELL sort method I am taking. What is SLL? Return type is single linked list. Sir, I am creating a new list is equal to new SL. At last, I will return that new list. Sir, what content will be there in the new list? Create one temporary node pointing to the head until the temporary node is not equal to null. What is the operation that we are doing? Into that new list, try to call sorted insertion. Already there, right? New list dot sorted insertion. We have, right? Or insert in ascending order. Let me give the data. What is the data, sir? Temp dot data. After inserting into the new list, this dot delete element. We have to delete that, right? That's all. Now temp is equal to temp dot next. Suppose if your list is not in sorted order, sir, I have 10 is there, so then 30 is there, so then 20 is there, so like that we have. Then what you need to do? Remove this and add it into the list. Remove this and add it into the list. Remove this, sort the list. Remove this, sort the list. Now you will get the sorted list. Clear, friends?
Yes.
So if you want, let me run both. So insert at last 400, then 200, so then 500, again 200, so then 300, again 200, then 600, like this. We are printing the list. So after that, what I'm going to do, list is equal to SLL dot, sir, list dot sort. After this, we can print the list. Sir, next and after that, list dot remove duplicates. Let us see. 100, 400, something like that is there. I sorted the list in ascending order so that all the elements will come after that. Then I am removing the duplicates. So both the functionalities I explained here. Do you have any queries up to this, friends? Please confirm. Is the requirement got satisfied or not? Array, please confirm.
Yes, sir. But sir, there is a uh, too much operation in there, sir. So we can also take the one data and we can loop. We can do it now.
Sir, which operation you are talking about?
I am
Sort?
no, sir. I'm asking about to remove the duplicated data.
This is the only option. And it is easy only. What difficulty you are feeling here?
Okay, sir.
Sir, can you explain the short function once again?
Sir, very simple. There is nothing here. We are giving a pointer to the node. We are checking, is that a current node data and the next node data both are same or not? Because I have already given the list is in sorting order. If there is any duplicate, what will happen? Those nodes will come in a sequence, correct? Am I right?
Yes.
Yes, sir.
Yes.
So if it is there in sequence, then I am doing that operation. moving the pointer to the next node by skipping that. Clear?
Yes, sir.
Yeah. Sir,
Sir,
can I go?
just one question here. So the node which gets deleted, right? But that will not be garbage collected, right? Because its next pointer is pointing to all already there. I mean,
No,
should
we
we?
deleted, right? We break the link.
No, you break the link. That's fine. From the linked list perspective, it's correct. That but from the garbage collection perspective, the previous node will continue pointing to the next node, and that will not be garbage collected, right? I mean, that we should also.
Yeah. Technically, whatever you told, it is correct.
Yeah.
But what we are doing, we are breaking this link means what? You are telling this link will be available. This link will be break, right?
Yes, this link will be break, but this link will
in
be
our
there.
point of view, this node, next node is this one.
Correct.
This only we are pathing, right?
Yeah. From
That's why
linked list perspective, it's perfect.
Yeah.
It's only from the performance perspective, it will not be garbage collected.
Yes. So clear? Sir, everyone understood the scenario? Please confirm.
Yes, sir.
Right. So next we have few more operations are there which are important. Please don't sleep so that I will conclude linked list today. What is the next operation is very dangerous, even difficult to understand. Don't ask me to repeat. Okay, please listen carefully. Reverse a linked list. Step by step I will explain. See, I have one linked list is there. Whenever you are calling this method, that entire list should be reversed. I am taking too many pointers to understand this. So consider this is nothing but a list with only 4 elements. Don't interrupt me. I will explain step by step. Whenever I am asking, is there any doubt? Then only just you can respond. Okay. Multiple examples I am going to cover. That loop execution till the end I will explain. This is nothing but a head. This is nothing but a tail. Assume the data is 10, 20, sir 30 and then 40. This is my original list. If you reverse, 40 should come first. Correct, sir? Am I right?
Yes.
Now, so what I am doing here, observe carefully. See, I am going to take some special nodes like temp is equal to head. Then temp previous is equal to null. Temp next is equal to null. Like this, I am taking some pointers. Now, tell me, sir, what is the, for your better understanding purpose, I am taking notes like this. Okay, just for your understanding purpose. If you reverse, what will happen? 40 should come here, 30 should come here, 20 and then 10. Correct, sir?
Yes, sir.
So links, it is difficult to explain. That's why I have drawn here. Now, tell me what is the temp value now? 10. 10 is the temp. Correct, sir? This is the temp?
Yes.
That means in this bottom, is it the temp? Correct? What is the temp previous value? Sir, temp previous is nothing but what? Null. What is the temp next value? Sir, temp next value is also initially null. Do you have any queries up to these pointers? Now I am taking tail is equal to head. Tell me which node is head. Tell me the numbers. Which node is head? Which node is head?
40.
Oi.
40,
10, right?
40.
In the original.
Yeah, in the original 10. Yeah.
10. So that 10 we are making as what? Tail. So modifications I am doing in the new list, sir. Is it tail now? Correct? Sorry. Not this one. Which is the tail? This one is the tail. Correct, sir?
Yes.
Let me draw in the old diagram also. This is nothing but tail. That means this pointer name is gone. Now, sir, what is the next code is? Observe carefully. Until the value of temp is not equal to null, I am doing 4 operations, sir. Temp next is equal to temp dot next. Temp dot next is equal to temp previous. Temp previous is equal to temp. Temp is equal to temp next. Please respond for my questions. I am taking a bold marker. Observe carefully. Sir, temp. Which is the temp node? Please confirm.
Head.
Head.
Sir, tell me the number.
10,
Tell me the
10,
number.
10, 10.
Is it null? No.
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 Then temp dot next. Who is temp dot next?
20.
20. The 20 will become what? Temp next. This is a temp next. In this new diagram, this is a temp next. Correct, sir?
Yes.
Now, your temp is there, right? Its next field will become temp previous. What is the temp previous value, Anna? Null. Correct?
Yes.
That null we are assigning to what? Temp dot next. Which is the temp? 10, right? Its next field I am assigning to as null. That means what? This link is break. Clear, friends, up to this? Now, sir, which is the temp? Please confirm. Which is the temp? 10. That 10 will become what? Temp previous. Then temp will become what? Temp next. This is nothing but a temp. Sir, which is the temp now? 20. Which is the temp previous? 10. This is nothing but after execution of the loop. Don't worry, I will repeat for the next case also. Sir, up to this you understood at least some points, right? Now I am changing the color. Sir, now observe carefully. Tell me which is the temp now. Sir, please speak. Then only you can understand well. Which is a temp? Tell me the number.
20.
20.
20. Is it null?
No.
No. Identify temp next. 20
30.
next field is what?
30.
30. That 30 will become which one? Temporary node next. Correct? Tn. 30 will become Tn. Clear, friends?
Yes.
Now, who is the temp previous?
20.
Oi.
No.
In the diagram. 10, right?
10. Yes.
The 10 will become what? Temp next. Who is the temp? 20. That 20 next field will become what? 10. That's why I have written a new diagram to understand the clarity. Clear, friends? Now, sir, which is the temp? 20. That will
20.
become what? Temp previous. Then temp will become what? This node. That is, temp is nothing but 30. Temp previous is nothing but what? 20. Like that we have. So the previous references. Okay. The previous references will be gone. Any questions up to this? The people who are unable to understand, just skip, later try to work out on it. Now, third time I am repeating. Now observe, just we are breaking the links, sir. That's all, nothing more than this. Sir, which is the temp now? Please confirm. 30, right? Yes, is it equal to null? No. What is its next node?
40.
That will become temp next. This is temporary node. Its next field is 40. Its previous field is 20. So that we can break this link and we can attach this to this one. So temp dot next is nothing but temp next. Then temp dot next field will become what? Temp previous. That means 30 next field will become what? 20. Then after assigning this one will become what? This one will become what? Temp previous, and this one will become what? Temp next. Sorry, temp. So now temp is nothing but what? 40. So temp next is also 40. 30 will become what? Temp previous. That means this link is break. Clear up to this?
Yes.
Now, sir, last step. Listen carefully. What is the last step? Sir, which is the temporary? 40. It is not equal to null? Yes. Sir, temp next is what? Null, right? That will become what? Temp next. So your Tn will become what? Null. So let us remove this from this diagram. Temporary next field will become what? Null. That means temporary next field is nothing but pointing to null. Sir, after that, temp previous, which is the temp previous 30. The 30 will become temp dot next. That means its next field will become what? 30. 40 next field will become what? 30. Then after that, temp previous is equal to temp. Sir, which is the temp? 40. That will become what? Temp previous. Temp will become temp next. Who is the temp next? I already told. Null, right? That one will become what? Temp. When temp is null, it will stop. So we got this particular link. At last, what is the name of the 40? Sir, 40 name is associated with temp previous and then. That's all, temp previous. Now, whenever 40 is assigned with the temp pointer, loop failed, right? Sir, can I assign head is equal to temp previous now? Yes. This one will become head. Anyway, already we updated tail. Now, automatically, these links got a break and new attachments has been happened. Sir, what is the algorithm that we are following here? Very simple, sir. Observe in a clear diagram. Sir, we identified some node called X. What is the previous node? Let it be A. What is the next node? Let it be B. So generally the attachment is like this, right? A next field, X next field. Sir, we are identifying this is the temp next, and this is the temp previous. So temp next field will become what? Temp previous. Like that we are attaching step by step. So that what will happen? Reverse you will get. Sir, you understood the point? Please confirm everyone. I know 50 to 60% of students are not understood, but you need to practice, then only you will get. Clear, friends? Please confirm.
Yes, sir.
Now, let me run this code and check really is that reverse operation is happening or not. Now you can see we have a list, right? Now what I will do, list dot reverse. Now immediately is that reverse is happening. You can check. $600, $600, $200, $200, $300, $300, $200, $200, $500, like that reverse is happening. Sir, everyone understood this one?
Yes, sir.
Next, we have one more operation. Is there two more operations? Let me talk about that. Sir, your favorite operation, copy list. I want to do copy. SLL copy list I am taking. What is the purpose of copy list? It will create a duplicate copy. It will create a duplicate copy. So for this, I need some special pointers like a head node is equal to null, tail node is equal to null for the newly created list. So temp node is equal to null. I am taking current node is equal to head. Sir, if a current node is equal to null, that means what? We don't have any list, right? Return null. Otherwise, what we have to do? We need to write coding for that. Assume just for our understanding purpose, I am taking node 1. What is the next field for this? Node 2. What is the next field for this? Node 3. What is the next field for this? Node 4. What is the next field for this? Node 5. Like this I am taking. This is nothing but a head. This is nothing but a tail. Like that we have. Now I want to copy this. I want to copy this. Sir, have you remembered here I have used some special terms. What is the special terms? Sir, head node is initially null. Sir, tail node is initially null. Temp node is initially null. Current node is nothing but what? Head. Like that we have. Sir, up to these pointers, clear? Please speak, friends. Clear up to this? Array, please confirm. Now,
Yes, sir.
what I am doing here is head node is equal to, I am creating a new node with the current node data, and the next field is nothing but what? Names. Sir, tail node is also I am taking as a head node. Now observe, and current node will become, please be on mute, current node dot next. Sir, observe, first 423 line, head node is equal to, we are creating a new node. What is the content? Sir, current node data, which is nothing but 1. What is the name of this? As of now, it is a head node. Then tail node is also same thing, sir. Tail node is also same thing. Then current node is equal to current node dot next. This one will become current node. Any questions up to this?
No, sir.
We copied one node. I mean, we created. Copy means what? Creating a new node, right? Now, sir, we have to repeat this. How many times? We don't know. Let me take a while loop. Until current node is not equal to null, repeat this process. What is the process? Sir, temp node is equal to new node of current node dot data, and the next field is nothing but what? Initially null. After this, tail node dot next field will become temp node, and the tail node will become what? Temp node. And as usual, current node is equal to, sir, current node dot next. Observe the steps. Sir, current node is not equal to null. True. Create one temporary node. This is nothing but what? Temporary node. Now, what is the data? Current node data. Sir, tail dot next field will become what? Temp node. And the tail node will become what? Temp node. And the current node will become what? Current node dot next. Now, what is the next step? Current node is not equal to null. This, it will create one more node. What is the name of this node? Temp node. Sir, temp node will become what? Tail node next field. Then tail node will become what? Temp node. Current node will become current node dot next. Like that it will create. Sir, clear up to this?
Yes, sir.
Now let me repeat one more time. Sir, is the current node is not equal to null? Yes. So create one temporary node. What is its data? Current node data. Tail node dot next field will become this temporary node. This temporary node will become tail node, and the current node will become current node dot next. Is current node is not equal to null? Yes. Create one more node, copy the content. This one will become what? A temp node. So tail node dot next is equal to temp node, and the tail node will become temp node. Okay, current node will become what? Current node next, which is nothing but null. It will stop. Now, sir, this list already we have a name. What is this list? We copied, right? We created a new list, right? So compulsory we have to create a new list is equal to new SLL. Sir, this new list head node is nothing but which one? Sir, already head node pointer is there. This new list tail node will become what? Sir, already one pointer is there. Just we are assigning that pointers and we are returning that new list. Sir, can you please execute? Yes, no problem. We have already list is there, right? SLL. So list 2 is equal to list 1 dot copy. Now what will happen? If you print list 2, a new list you are going to get. Why copy method is raising error? Because the method name we have taken like copy list. Sir, is it copied? Yes. Sir, is it possible to modify the above list? Yes. Is it going to reflect the new list? Definitely no. So if you are doing modifications, 2 independent lists are there. Sir, everyone feeling comfortable up to this copy list operation? Please confirm.
Yes, sir. But one query here. So after copying, we will not be maintaining the size for the new list, copied list, right? So, so some operations like I guess for delete operation we use index, right? I mean, for some operation we need size also. We need to take it over here. Some operations may not work with new.
Yes. What you need to do here? Maybe with respect to that, better at the last, what you have to do is whatever size is there for the current list, that size you can copy for the new list also, right?
Yeah.
Otherwise, you can implement a method for counting. Just you can count the original data and then you can copy that.
Copying
we can
would
write
be
the
the better.
code. Yeah, that's what. Clear, guys? Sir, if you are clear, there is one last operation. I will explain that. Clear?
Yes, sir.
Right. Now, listen, friends. Almost last operation. Of course, I'm taking this only for this some new batches. Comparing list objects. Sometimes they are going to ask, can you please compare 2 list objects? Let me take static method like boolean compare. I will pass 2 nodes, node temp1, node temp2. Sir, it is a very easy code, recursive code. That means assume I have one list is there with elements 10 and the next node is nothing but 20. Okay, and the next node is nothing but 30, like that. There is one more list having 10 and then 20 and then 30 or 40. So this is a head node, this is a tail node with respect to list 1, head node and a tail node with respect to list 2. So how you can compare these two? Sir, I will pass this one as a temporary 1 and this one as a temporary 2. Now we have to compare. Sir, I am going to do one base condition. If a temp1 is equal to null and a temp2 is equal to null, both the lists are not existed, then tell me, if you compare, what value we have to return? True or false? True. Very good. Because both lists are not existed, that means same. Now, if temp1 is not equal to null or temp2 is not equal to null, that means any one list is empty, or temp1 dot data is not equal to temp2 dot data, that means which value we have to return? False, right?
False.
Otherwise, what I am doing, array, can you please compare recursively for temp1 dot next, and what is the next one, temp2 dot next. I think it is sufficient, no need to write anything. Now what will happen, because first condition not satisfied, second condition not satisfied, this one will become temp1 temp1 temp2. Now it will compare both conditions not satisfied, temp1 temp2. Sir, first condition not satisfied, but second condition satisfied. Because is a temp1 is null? No. Temp2 is null? No. Temp1 dot data 30. Is it not equal to 40? Yes, condition true. It will return false, saying these two lists are not same. Clear, friends?
So we are passing actually heads of two lists, right?
Yes, exactly. That's why it is a static method. Let me execute and I will show you. Sir, here we have two list objects are there, right? System dot out dot println SLL dot compare. What is the first one? List dot head node I am passing. Second one, list2 dot head node I am passing. What is my expected output? True. True or false? Sir, it is coming false. But both the list content is same, right? Why it is returning false? Can anyone check? Anywhere spelling mistakes or logical mistakes? Temp1 is, sir, if temp1 is equal to null, temp2 is equal to null. Correct? Not equal to null. No. If it is both are null, here it is not equal only. Temp1 is not equal. Okay. Either first null or second node null, or the data is not same. In such cases, that will be good. Now check. Yes. Sir, clear? Now
Yes.
let me add one more item into the list. After copying, let me add one item to the list2. List2 dot insert at last. I am adding 999. One extra item I added. Now check false, because list2 is having one extra item. Clear? Any questions?
The two lists are same and the same size is there. Elements also same, but in a different order. So in
It
this
will
case also
return
it is
false.
false only.
Yes,
But,
yes, because data also we are comparing, right? If the list is in different sizes also, it will work. That's why here I have taken.
but content in the both the lists same, right, sir? But in the different order, then also it will return false.
Yes. Why? Because we are moving the pointers continuously, right?
Hmm.
If
But
temp1 content and temp2 content are different, it will return false only.
but the content is same, right, sir?
See,
In
you
this,
need to see it is a list, right? Name itself is giving clarity. There should be some order. If it is available somewhere else, how we can say both are same? No, right? Then if you want, irrespective of the content, try to sort the list, both list, so that they will arrange in some order. Then you can compare.
okay.
Clear, guys, everyone?
Yes, sir.
Yeah. Right, friends, that's all about single linked list cinema. What we have, almost 400 lines of the code we have seen, 400 to 500 lines of the code.